So I'm just reading the comments. Link is not working. Yeah, so they are working on it. The mail link is also not working. So I'm just reading the comments.
It's live on YouTube. They can now click the link and they can watch it on YouTube.
Okay. So email link is not working. So does they know Sakshi then not join from the YouTube? Because we sent a Zoom link, right? Mail link.
Yeah.
Okay. Very
now
good.
working, it's working, yes.
Right. Okay. The Zoom link is working. Good. From LMS, it is not working. LMS, it is showing 500 errors. Okay, so we will start at 7:05. So we told them to join group. I think there is some. So still 589. I think they're joining. So we will start at 7:05. So keep chat everyone till lecture. Okay. So I'll. Yeah, thank you. Thank you. It's not working. Yeah, I think there is some delay on the YouTube. Yes. Most of you watching a video in the YouTube. Link not working. Okay, so sir, from mail we can connect with Zoom. Okay. Okay, so it's 7:05, so we will start. So Sakshi, can I start, right?
Yes, Venu, you can start.
Okay, fine. Cool. So let me record it. Is it required recording or it was okay? Yeah, I think recording also started. Yes. So good evening, friends. First of all, thank you for coming on the Saturday evening also. Right. Cool. So I'll share my screen and then we'll start. So I hope, can you all see my screen?
Yes, Venu, they can.
Okay. So let me change the view. I think. Standard. Okay. Okay, right. So cool. So friends, I'll introduce first myself and then I'll start the class. So I am Venugopal Panchumarthi. So working as a senior curriculum engineer at Masai school. So a small introduction about myself. I did my BTech from IIIT Nujvid, so in the branch of computer science, and I did my MTech from Hyderabad Central University, so specialization in information security. And I cleared GATE and both UGC NET assistant professor and JRF with 99.48 percentile. Right. So I was little studious back then. Right. Then I worked as a SD1 at EA Sports. So I couple of months I worked there. But I was more interested towards teaching. So I resigned that job and I joined as Masai as a senior curriculum engineer, at Masai. So I have close to five plus years of teaching experience I had, and in Masai and outside Masai, close to I mentored 5,000 plus students. So this is small introduction about myself. Now with that, so let's start the show. So okay, so recursion. So friends, before I start explaining about concept of recursion, so for time being, let's play some small game here. Okay, so that game is, so the very famous game, which is Tower of Hanai. So I know you all might have seen this game somewhere else. So this game is having some rules, friends. So first I'll tell the rules. Okay, so the rules are, so there are some discs are there here. So if you see disk 1, disk 2, so 3 discs are there. So you need to move all these discs from one place to other place. Okay, so 3 discs here. So let me call this is as a source, and let me call this is as a destination, and let me call one as a auxiliary, which means you can think of auxiliary, or this one you can think of a helper node also. So helper. So 3 poles are there, and every pole we are having some certain discs are there. Okay, so now friends, you need to move all these discs from source to the destination, but having some rules are there. So you need to follow those rules. What are the rules are? So first, rule number 1. So rule number 1, at any point of time, you can pick only one disk at a time. So at a time, only one disk is allowed. So only one disk is allowed at any point of time. So that is the rule number 1. Okay. And the second rule is, so if you see here, total 3 disks are present. Na? So this is the bigger disk, compared to this disk. This is the bigger one. Now compared to this one, this is somewhat bigger. Therefore, at any point of time, while you are moving one disk from one pole to another pole, so on top of the bigger disk, you can keep the smaller disk. This is perfectly allowed, no problem. But on top of the smaller disk, okay, you cannot place the bigger disk. That is the only condition, friends. On top of the smaller one, you cannot place the bigger one. Whereas on top of the bigger one, you can place the smaller one. So these are the 2 rules. 2 rules are there. Now at the end, you have to move all these 3 disks from here to here. Okay, so that is the game. I hope you understood this game. So I'm pretty sure this game you might have played somewhere in your college days or somewhere else. So if you ask me, so when I'm in college, so there are some technical fest will happen, or some cultural fest. So in that fest, they used to keep this game. So you have to do it in less than some time. So they will set some, let's say, they will give usually 4 discs are there. So they will give 1 minute or 2 minutes time, and you need to move it. So you will get some prizes, something like that. So I played when I'm in my college days. Now this at the end of this class, so I am pretty sure you are going to solve this question very easily. So that is the target, friends. So this can be done easily with the help of recursion. With the help of recursion, we can solve this question very easily. So that is the target. Okay, cool. Right. So here only 3 discs are there. It is very easy, friends. So let me play here. So later also you can play this game. So first I will move. So see here I'm playing. First I will move this disk here. then I will move here, then I will move here. After that, I will move this one here, then I will move here. After that, I will move here. Then finally, I have moved. Okay, done. Done. So if there are 3 disks are there, it is very easy, friends. But what if disk size are increased? If there are 4 disks are there, so then that's a little problem here. So let me do this. So first I'll move here, then I'll move this one here, then I'll move something like this, then I'll move something like this here. Okay, so then like this, like this, like this. Okay, then something like this. So I'm just randomly playing here. Okay, so it can be right or wrong. So okay, so I'll move this one. I don't know whether I'm doing right or wrong, so I'm just randomly moving. Okay, so like this, so like this. Okay, so let me put it here like this. Okay, this is smaller one, right? Okay, so I don't know, I'm going somewhere wrong. Okay, like that. So you need to do it in less number of moves, friends. So if it is in 3 disks, just like that, I have moved. But here 4 disks are there, and I'm having some confusion to play. Finally, I'm not successful here. Okay, let me increase the 5 also. Then see, 4 itself, I'm unable to solve. Then if 5 disks, if 6 disks, if 7 disks, then it is really difficult, right? So at the end of this class, we will write a code using recursion. Very simple code, friends. I'll make you guys also to write a code. Very simple one. That is the target of this today's class. Okay. But before writing the code for this, so you should know the basic stuff with respect to related to recursion. Okay. Cool. Now let's start here. Okay. So recursion, friends. So I hope you understood at the end what is the end goal of the class. So we have to solve it. We have to solve that problem of Tower of Hanoi, right? Cool. So I'll take one simple problem. So the problem name is find the product of all integers from 1 to n. So it is nothing but a n factorial. So if the input will be 5, the expected output will be 120. So 1 into 2 into 3 into 4. So you need to find the product, friends. Okay. So there are simple code is there. So see it on the left hand side. So I wrote one code here. So friends, I'm writing only the pseudo code. So this is not related to any particular programming language. It is simple pseudo code, friends. Okay. So now if you see this code, so first I am passing a n value. Okay. And I have taken one variable result and I am running a loop. How many times this loop is going to run? So starting from 1 going till n. So result is equal to you are multiplying with the I value. And then finally, whatever that result that you are going to returning, friends. Very simple code here. So I hope self-explanatory this is. Now same code, you want to write it in the recursion. So as of now, I haven't teach anything with respect to recursion, but I wrote something here. So right now, we're not going to see this code, but just like that, I have wrote here, friends, one code. I don't know whether it is right or wrong also. Just like that, I wrote it. Okay, cool. Now, whenever, let's say if this problem, when you're trying to write this code, so definitely you might require some prerequisites, friends. What are the prerequisites that you require? So first of all, you should know like how to declare a variable. Then you need to run a loop. So you should have some knowledge about loop. Without having a knowledge of loop, you can't solve this question. So for every concept that you are going to learn, there are some prerequisites are there, friends. So if you know those prerequisites, then only you can able to solve that question. Right. So similarly, to learn the recursion also, some prerequisites are required, or you need to learn it in some flow, friends. So when we are learning programming language, let's say, first we will start with simple data types. Then we will start with if else. Okay. And then we'll start with the loops, then arrays, some functions. So like that, one particular order we are going to learn. Correct now? Here also, when you're writing that recursion code, you need to follow some order, friends. In fact, that is the order which I have followed. So I will teach the same order what I have followed for you also. Okay. Next. So learning the recursion. So how should I learn the recursion? So usually I'm going to divide this session into two parts, friends. So part 1 and part 2. Okay. So first part 1. So in first part, what I'm going to explain is, okay, so if any recursion program is given to you, you don't know whether it is recursion or not, but some recursion program is given to you, you want to trace it, friends. So first we will focus more on the how to trace the recursion programs. Okay, so what does meant by tracing? Some recursion code will be given to you. Some recursion code will be given to you, and you need to say output of that code. You have to say output of the code. Okay, so because by doing part one, what will happen now? So you are going to see lot of the already written recursion programs, friends, so that you will get to know, okay, this is how I have to write a recursion program. So I have taken so many all different models I have taken, and I'm going to explain now, friends. So if recursion code I'm going to take, and I'm going to dry run this, okay, how this recursion code is working. After that, once if the part one is completed, so that you'll get a good understanding about, okay, this is the recursion. Then in part two, I mean, in the second part, what I will do is, so let's, okay, so we will start writing the recursion programs for some problems. Okay, so this is the flow, friends. So first part one, I'll take some already existing recursion programs and I will trace it. Okay, how it is happening, all these things. Next, part two, let's start writing the recursion programs, friends. So people are asking, sir, what is recursion? What is that? You will get, so please have some patience. You will get everything about it. So some patience you have. So at the end of the session, I can promise you, whatever the doubts that are there with respect to recursion, all are going to be cleared. That is my guarantee. Okay. So kindly bear with me. So have some patience. It will be clear. Okay. So as I told, first part, taking some recursion programs. So please everyone do stay with me and take pen and paper and active in the class. Okay, now please be active in the class. Take pen and paper. Now I am going to take some programs and I will explain, friends. Okay. So first let us start the first question. So first we'll take one question and then we will start. First. Cool. So always if you take any program, execution will always start from the main function. Always the execution starts from the main method, friends. Okay. Now who will going to call this main method? Who will going to call this main method? So operating system is responsible for that. Operating system will call this main method. So, but before calling this operating system, if you write any program, what will happen? So first compilation will happen. So whatever the code that you write, it can be C, C++, Java. So that will be given to a compiler. Compiler is going to check all these statements. If there is no any syntax or semantic errors, then compilation will be done. Then next execution process will be started. So once if execution is done, then we can see the output. So during this process, we are going to involve the operating system, friends. So now operating system is going to call the main method. Okay, so operating system is going to call the main method. So whenever if any function call is happening, so you need to know there is something called memory, friends. So for every program, certain memory is going to get allocated for every program, friends. Okay, so that memory is going to divide it into three parts. So first part will be static memory. So let me write it here. So this part, it is nothing but a static memory. And second part will be heap memory. And the next part will be stack memory. Next part will be the stack memory. Okay. Total 3 memory parts are there, friends. Now, whenever if any function call is happened, so main is itself is one function call. Okay, now main is itself is one function call. So whenever if one function call is happened, so respective activation record is going to be pushed inside that stack. See, people who are listening these terms for the first time, so kindly listen, friends. So there is something called as a activation record. Activation record. So for every function call, one activation record is going to be created in the stack memory. So here, if you check, friends, so this part is for the stack memory and this part is the heap memory. So usually, so here to here is the stack memory and here to here is the heap memory. So there is no fixed size of stack and there is no fixed size of heap memory, friends. For example, if you are calling a function, as I told, one activation record will be created. Like that, many function calls, many activations records are going to be get created. So in such case, if stack memory will require extra space than those allocated, then heap memory is going to help to stack memory. Okay, so I came to know that you will be requiring some extra memory. So then it will take, so from my side, you can take some part. From my side, you can take some part. So like that, both stack and heap memory is going to compromise, friends. Once if completely full, both stack and even after compromisation of the heap memory also, if completely full, then you'll get a stack overflow error. Most of the recursion problems, you are going to end up in a stack overflow error, friends. Okay, so now let's come back here. So let us assume this much is the stack memory and all the memory is going to divide it into some equal sizes of the blocks. So if you study operating system and computer organization, so there they might have studied concepts of paging, concepts of, cache memory, all those things, but let's not go in detail about all those concepts. So which is out of our scope. Cool. Now activation record created, friends. So here to here is the stack memory. So let me take here to here is our stack memory. So just increasing. Okay. So here to here is our stack memory. Okay. For the first time, activation record will be pushed inside to the stack, which means a function called main is there now. So its activation record will be pushed inside the stack. See, for the one problem, I am explaining in detail. From the next problem onwards, I'm not going to teach all those concepts. Okay. So one activation record got pushed inside that stack. Next. So now main is going to call the function fun with the value 4. Okay. Now the main is going to call this function fun of 4. So again, this is also a function call. Again, fun is also a function call. Therefore, in that function call also, activation record will be pushed inside this stack. So what is meant by activation record? So this activation record is going to contain complete information about this function call, friends. So complete information, as I mean to say, for example, this function call is passing a n value called as 4, okay, which means this n is local variable to this function. So it will store its value n is equal to 4, and then any other variables that are part of this function, those details also it is going to store. Okay. Now when now execution started, so is n is equal to 0? No. Then else case is going to get executed. Now else case is containing total 2 lines. One is line number 1, that is again you are calling fun with another value, and second there is a 2 function calls are there, friends. Now first function call, again you are calling fun of n minus 1, and then second statement will be print n is there. So for the first time it is going to call, I'm writing line number 1 for your reference. So it will call again fun of. Now this is the n value, right? N value will be 4. So this f of 4 is calling another function whose value will be 3. Because n minus 1 now, which means now control from here, okay, it will go to the next function call, next block by a new function call. Therefore, another activation record has to be created. That is f of one more activation record, but this time the n value will be 3. So now what will happen now, friends? Since you have called this function call, right? Therefore, immediately control will go and execute the next function call with the value 3. Then what about the second statement? Total 2 statements are present inside this else block. Once if first statement is completed, then only control will come and execute the second statement. Till then, it won't even check this. Okay, so it won't even check this, friends. First f of 3 has to be completed. Then the second line number 2, that is print n, is going to get executed. So till then, it won't even check this function call. Now control will call again f of 3. Now this time also control will go. Now this time n value will be 3. Now is n is equal to 0? No. Then again else, these 2 statements are going to get executed. Okay, so I'm writing again those 2 statements. So first line number 1. So first line number 1. So you are calling fun of 2. Okay, so whenever if new function call, again another activation record will be created. This time n value will be 2. Now, so friends, when from here, if this function call is happened, so whatever the address from where what address it is storing, that address also it is going to store here. Because otherwise, how we know? From here I have to go From here I have to go. So whatever visualization that I'm showing here, everything will happen in the computer memory. So it should supposed to remember from where to where I have to go. Correct now? Okay. So now first one is again f of 2 I am calling, right? So this time a new n value, that is 2. Now again is if his statement is true, no, then again else case is going to get executed. So later this line 2 will be executed. Now again when you are calling f of 2, so this time, so previously this is the n value, now this is the new n value. Now again first line number 2. So when you call f of 2, again if condition will be false, so else it will go, it will call one more function, that is fun of. Okay, so this time the n value will be 1. So new function call, right? So line number 1, again we will call f of 1. Once if this is completed, then line number 2. Till then it won't even execute, right? So now again you are calling fun of 1. So again you are calling fun of 1, friends. Now this condition will be false, then again else is going to get executed. So then again this time also you are calling fun. Okay, but how this time? This time the n value, so n is equal to 1 completed, friends. So next time you are calling n value with 0. So n value with 0. Okay, so again the first line number 1 you are calling. Now listen carefully here. So this time you are calling fun of 0. Once it is completed, then line number 2 will get executed. Okay, so now when you are calling next n value with the 0, now it is interesting. Observe everyone. Okay, so now is n is equal to 0 at this point of time? True. N is true, friends. So it will stop because we have written the return statement now. So return means stop the execution. So when it encountered the return, which means its program execution is completed. Program execution is completed. So whatever the activation record that got created for this function with the value 0, that is going to get deleted from the stack. Because this is the activation record created now. So it will be deleted from the stack. Now this will be no more, friends. So if you see here, it will start from here. The execution will be and coming like this, then coming like this, then from here coming like this, then from here coming like this. Okay, so which means it is completed. The moment when this function execution is completed, the activation record is going to get deleted from the stack. Next, you are going to execute the line number 2. Now, line number 2, what is the statement, friends? Print n, which means now it will print the n value. So what is its n value? See, these two statements are part of this one, which means this is the children and it is the parent. Now it will ask the parent, please give me my n value. So now f of 1 says that, so your n value will be 1. Therefore, it will print 1. So if you see the output that I'm writing here, so first it will print that value 1. So from here, this is also completed. So completed means now I am going here, friends. Now I am going to f of 1. Now if you see, so f of 1 under this two statements are present. These two statements are also completed, which means now f of 1 is completed. The moment it knows that f of 1 is completed, whatever the activation record created, it is also going to get deleted from the stack. Okay, it is also deleted. Next, line number 2. Now what is this line number 2, friends? F of 2. Okay, so print of n. Okay, so I'm doing print of n. So what is this n value? It will ask to parent. Parent is containing all the information, friends, in an activation record. Okay, na? So parent is giving that n value will be 2. Then it will print the 2 as the output. So it will print 2 as the output. Then this is also completed. From here, control will be coming. Now you are started and you are ended, which means f of 2. This activation record also going to get deleted from the stack. Okay, this is also done. Now next, line number 2. Now here again, what is the line number 2? Print n. So which means print the n value. What is the n value? So n value, it will be asked to parent. Parent gives 3. So that 3 will be printed here. Once this is also completed, this is also completed, then control will goes there. Now f of 3 started, f of 3 completed. So all the activation record also going to get deleted from the stack. Okay. Then next statement, second, print n. Now what is the n value, friends? So ask to parent. Parent is giving n is equal to 4. And that 4 is also going to get printed. Okay. So we are coming here, done. Then we are going f of 4. Now f of 4 is also completed. So this activation record also going to get completed. Next, once if f of 4 is completed, then control, which means now the recursion code is completed, friends. Now control will goes back to the main. So now if any other statements that are present inside that main, it is going to get executed. But there is nothing present inside that main, right? Therefore, main execution is also completed. Main execution is also completed, which means the activation record which you created for the main also going to get deleted, and then control will finally returns to the operating system saying that program execution is completed. So this is what will happen, friends. If you write this code and execute, so you can simply see the output as 1, 2, 3, 4. But internally, what will happen, starting from the code compilation, memory allocation, all these things, this is the backend story. Okay, I haven't even covered 100%, but only memory part, some part I have taken. But the whole story is this. Okay, so if you dive deep into the operating system memory concepts, so there will be like separate course actually, that is. But to be brief, this is what will happen, friends. Okay, I hope is this clear? I'm assuming that, right? Okay, perfect. Now, so code is completed. This is the output that I have seen. Now we have to check what is its time complexity and space complexity. So for any recursion program, friends, you should identify its time complexity and its space complexity. Now remember, any recursion program that you take, any recursion program if you take, okay, so its time and space complexity depends upon the following things. So first let me talk about the time complexity, and then I will talk about the space complexity. So first, friends, so how can you say that what is the time complexity of this recursion program? So time complexity will be depends upon the number of function calls. So always in recursion, time complexity will be depends upon how many number of function calls are present. Function calls. Okay. Function calls approximately. Now, friends, here, if the n value will be 5, if n value will be, okay, 4, if n value will be 4 here in this problem, so total how many function calls? So you should not count the main. So if n is equal to 4, 4, 3, 2, 1, 0, approximately 4 to 5 function calls. If n is equal to 5, then 5 function calls. If n is equal to 6, then 6 function calls. Therefore, here, whatever the n value, there are approximately those many function calls are present. Therefore, the time complexity of this problem will be big O of n. So order of n, friends. So in any recursion program, time complexity directly depends upon the number of function calls. Okay, very good. Next, we have to say what is its space complexity. Next, what is its space complexity? Okay. Now, so the space complexity in the recursion will be depends upon the height of that recursion tree. So whatever that I have drawn here, so this will be called as a recursion tree, friends. So this will be called as recursion tree. This will be called as a recursion tree. Okay. Now, what is the depth of that recursion tree? So if you check here, 1, 2, 3, 4. 4 depth is there. So 4 plus 1, 5 function calls you are trying to store here. So if n value will be 4, the depth will be 4. If n is equal to 5, 5 is the depth. If n is equal to 6, 6 is the depth. So for every one function call, one activation record you are creating the memory. So overall, the space complexity will be depends upon the depth of the tree. Depth of recursion tree. Depth of recursion tree, friends. Depth of recursion tree. So now if you see space, this space is going to become order of n. Why order of n? Because if n is equal to 6, total 6 function calls. N is equal to 7, 7 function calls. So that is how you need to analyze the space complexity of a recursion process. Okay. Now this is one problem where I have covered everything about recursion. Okay. Now I will try to answer like what is the recursion? Simple, friends. So recursion is nothing but, if you see, first time I am calling the function f with the value 4. Next time I am calling f of 3. Next time I am calling f of 2. Next time I am calling f of 1. Same function calling again and again and again with by reducing the size of the input till it reaches stopping condition. So here when n becomes 0, the program we are going to stop. Friends. So that stopping condition, whatever we have wrote now, so this is also called as a base condition. So this is also called as a base condition. Base condition. For example, here, if you did not properly write this stopping condition, then another activation record, one more activation record, like that, keep on activation records are going to be pushed inside that stack. So in that case, you are going to get a something called as a stack overflow error. So this is the reason behind to get a stack overflow error, friends. Okay. Cool. Very good. Now, so friends, for the first problem, I have explained in detail. So from the next problem onwards, so let's take the problem and we will run the output. Okay. So now this is the second question. Now let's understand the what is the output for the second problem. Okay. Now, if you see, friends, the main so function I am calling, and okay, else is containing two lines, line number 1 and line number 2. Let's try to dry run this. Okay. So first, the main always execution will start from the function fun. So which means I am calling this function 4. Now, friends, now I am not going to draw this memory, and I'm not going to explain all these things, because same explanation will valid for the next problems also. Next problem also. Okay. Now check this time what is happening. So I am calling this function f of 4. Now the n value will be 4 first time. Now if n is equal to 0, no, then these two statements will be executed. Now if you check here, these two statements, here first time you are printing that n value. So first statement you are printing that n value. So n value will be 4. So I'm writing output here. So first time output will be printed 4, and then second I'm calling this function with n minus 1. So with n minus 1. Okay. Now this is the n value. Next. Now again function 3 will be called. So now again n value will be 3. So now when again n value will be 3, two things will be coming here. So n is, because it is not equal to 0 now. So else case line number 1. So print n. N value will be 3, right? So 3 will be printed. So output will be 3 here. Then again you are calling second with n minus 1. So which means f of 2. Now this time the new n value will be 2. Now again this condition will be false, else these two statements are going to get executed. Okay, so what is the first statement? Print n again. So which means n value will be printed. So this is the n value. So 2 will be printed, and second, so output 2 will be printed, and again it will call f of with 1 because n minus 1. Okay. Now next, this is the 1 value. Now again f of 1, because it is not equal to 0. Not equal to 0, therefore else. So line number 1, so print n, which means 1 value will be printed, n value will be printed. Then second again it will call f of 0. So here n value will be printed now. So output will be 1. Output will be 1. Okay. So now when you call f of 0, now this is most interesting. So when you call n is equal to 0, so it will stop, friends. So the program execution will be completed. From here, there is no tree. Why? Because we have written the stop condition now. So it won't go further. Now always, once you draw the recursion tree, start the code from here and start executing. So print 4. So first the output 4 will be printed. Then it will go here. 3 will be printed output. Then it will come 2. So 2 will be printed. Then it will come. Then 1 will be printed. So coming and going here. So now f of 0 activation record is going to get deleted. F of 1 deleted because it's completed now. F of 2 deleted. F of 3 deleted. F of 4 deleted. So from where did you started? If you reach to the same place again, which means program execution is done. So what is the output of this code? What is the output of this code? 4, 3, 2, 1, friends. Okay. So output will be 4, 3, 2, 1. So here print is a simple printing that output. Someone is asking what is meant by print. So it will print the output. So it will print the output. Okay. So in JavaScript, you can write console.log, or in Java, you can write system.out.println. In C programming, you will write printf %ld, like that, friends, like that. Okay. So is this clear? I hope. Right. So please listen carefully, friends. So at the end, I'll share these notes. So whatever I am writing here, that I'm going to share with you all. Okay. Next. So second one is done. Okay. So someone asking. Next question. Just now slowly the level of difficulty is going to be increased. Okay. So kindly follow. Okay, so I'll decrease the speed, right? Okay, so I'll decrease the speed, friends. I don't know, I'm going little fast. Yeah, cool. So next question, third question. Third question, see here. Now, always, friends, the program execution will start from the main method only. Okay. Now, this is little different question compared to previous one. So inside main method, I'm calling that function 4. So which means I'm calling this function 4 here. Observe this carefully. Okay. So the n value will be 4 here. If n is equal to 0, the program is going to return, which means program will stop. But n is not equal to 0, na? Then else. In the else case, total 3 statements are present. 1, 2, 3. 3 statements are present, friends. Then all these 3 statements are going to get executed. All these 3 statements are going to get executed. So what is the first statement? Fun of n minus 1, which means fun of n value will be 4. So n minus 1, which will be 3. Fun of 3. That is the first statement. What about the second statement? Second statement will be print n. So whatever the n value, it will be printed. Once it is done, then the third statement, again fun of n minus 1 will be executed. But friends, once if this is completed, then only this and this I'm going to get executed. That is the reason I am not even writing these n values also. Because it don't know, friends, at this point of time. Why? It is waiting for completion of this function call. Okay, now? So now what will happen? Now you are going to call the f of 3. So f of 3. So now what happens? N value is going to become 3. Now again, when n is equal to 3, it is not equal to 0. So else case, all these 3 statements are going to get executed again. Okay, so now I'm drawing again all the 3 lines. Because all these 3 lines are going to get executed. Now remember, friends, whatever f of 3 will be responsible for all these 3 lines. Okay, now what is the first line? What is the first line? F of n minus 1. So 3 minus 1, which will be 2. 2, because n is equal to 3, right? Then second, print n. So it will print the n value, and third, it will print the fun of n minus 2, n minus 1. But at this point of time, it won't even touch these values also because it doesn't know. First, it needs to finish the f of 2. Okay, now? Now again, I'm going to call the fun of 2 again. So friends, this time the n value will be 2. Now again, n is not equal to 0. Therefore, else all these 3 statements are going to get executed. See, you need to have a lot of patience to solve these recursion problems. Okay. Now this is the n value, friends, f of 2. So again, all these 3 statements we have to execute, right? So first statement, fun of n minus 1, which will be 1. Okay. Then second statement, you have to print the n value. And third statement, fun of n minus 1 will be executed. But you don't know what is these n values. You first, it needs to finish this f of 1, friends. Then next, what will happen? We are going to call again this 1 value. Okay. Now again, n is not equal to 0. Na? Therefore, again, all the else 3 statements are going to get executed again, right? So now first statement, fun of n minus 1. So now n value will be 1, right? So fun of n minus 1 will be 0. So once it is completed, then line number 2, print n. Once it is done, then line number 3, again, fun of n minus 1. So n minus 1. Okay. Now it is interesting, friends. Observe carefully. So you are calling f of 0, right? Now you are calling f of 0. Now what will happen is n is equal to 0. True, right? True. Therefore, it will return. So it won't return anything, friends, just some random. So when you see f of 0, it will be returned. So which means it will be stopped. So this function call execution will be done and it won't return anything. Okay, done, friends. Then once if this is completed now, okay, now the second statement will get executed. What is the second statement? Print n. Okay, what is the n value? It will ask to its parent. Okay, parent, please give me my n value. Then parent will give n value will be 1. So that 1 will be printed. So the output I am writing here. Output I am writing, friends. So first n value 1 will be printed. Then what will happen? Once if second is completed, always top to down and left to right. That is how the any recursion program will work. Okay. Now, since the second is also completed, now the third line. Now it will replace this n minus 1 with 0, friends. Why? Because n value will be 1. Na? So it will say that n is equal to 1. Then overall, this value going to be replaced by 0. Now again, fun of 0 will be called. So when fun of 0 will be called, this condition true. So inside this, nothing. Therefore, it will simply return, friends, which means this is also completed. Once if this is also completed, actually, these 3 branches are under this f of 1, which means now I can say f of 1 execution is completed. So if I call f of 1, as of now, if I am calling f of 1, all these 3 branches are there. At the end, output of f of 1 is simply one number. This is just output of f of 1. Okay. So then this is also completed, friends. Now the second line, which is corresponding to f of 2, will be executed. Okay. Now what is n value? So ask to parent. Parent is saying that n is equal to 2. So that 2 value will be printed in the output. Okay. So 2 will be printed now. Right now? Now this is also completed. Then line number 3 will be executed. Now what is the line number 3? Again, f of n minus 1. Now it will ask to its parent. Parent give n is equal to 2. So 2 minus 1, which will be 1. Now again, I am calling with f of 1. Now n value will be 1, friends. But when you call f of 1, so don't you think again it is going to repeat all these things? Tell me, friends. So don't you think when I call f of 1 again, so whatever these 3 lines are will again comes here. So I'm not going to write all those things, friends, because all these will be again present here. But ultimately, we require that output. Ultimately, we require that output, friends. So now what will be the output if I call f of 1 again? If I call this f of 1 again, what will be the output? We already know, friends, its output will be 1. Therefore, it will print 1. So output of this f of 1 is nothing, but it will print 1 as the output. Therefore, I'm not writing again. So I'm writing directly its output will be 1. Okay, done. So this is also completed, friends, which means under f of 2, total, these 3 branches are there. And what is the output? Now, this complete block is corresponding for these complete 3 numbers are the output of f of 2. These complete 3 numbers are output of f of 2. Okay, cool. Now, this is also completed. Okay, na? Next, print n value. Now, n, it will ask the parent. Now, this time parent is saying that print 3. Therefore, output 3 will be printed. Once this is also completed, now again it will ask f of n minus 1. So parent will say n is equal to 3. So 3 minus 1, it will be replaced by 2. So now, friends, again you are calling f of 2. So you already know that output of f of 2. What is the output of f of 2, friends? 1, 2, 1. Therefore, if I call again this f of 2, same tree is going to be repeated one more time. Therefore, I'm to save the time, I'm directly writing output of this f of 2 will be 1, 2, 1. Okay. So I'm writing here 1, 2, 1, just to save some time. Okay. Now f of 3 will be completed. So friends, if f of 3 completed, then what does it mean? Under this, all the branches are completed. So f of 3 is done. Therefore, can I say that this complete output is the f of 3? So can I say this? Yes, of course, because f of 3 completed. So this is the output starting from here to here is the f of 3. Okay. So now f of 3 is also completed. Next, again, line number 2 will be executed. Now print n, ask to parent. N is saying that 4. Then it will print the 4 as the output. Okay. Once it is done, next f of n minus 1. Now this time ask to parent. Parent is saying that n is 4. So 4 minus 1 will be 3. Now again, if I call f of 3, don't you think whatever that f of 3 output will be repeated one more time? Yes, of course. So again, same output is going to be repeated, friends. So which is nothing but 1, 2. I'm writing complete this one more time. Okay. So 1, 2, 1. So 1, 2, 1, and then 3, 3, and then 1, 2, 1. So this is the again one more output of the f of 3. F of 3. Okay. So f of 3, friends. This is the output for the again f of 3. Now, can I say that This complete output is for f of 4. This complete output is for f of 4 because I'm calling f of 4. F of 4 is completed. So this is the complete output for f of 4. Now, if I ask what is the output of f of 5, can you able to say easily? Yes. If I ask output of f of 5, what will be happen, friends? So first, whatever the output of f of 4, followed by 5, and then followed by output of f of 4. Simple. Simple, right? So easy. So if I call f of 5, f of 4, 5, and output of f of 4, which means same thing, 5, and one more time, all these things are going to get repeated, friends. That is the output of f of 5. F of 5. Understood? So this is how you need to draw the recursion tree so that things are going to become very easy, friends. Okay. So now if you analyze the time complexity, for that, cool. Before analyzing the time complexity, okay, can you tell me what is its space complexity, friends? So always space complexity will be depends upon depth of that recursion tree. Okay. Now if you take the n value, so if n is equal to 4, f of 3, f of 2, f of 1, f of 0. So if n is equal to 4, total 4 edges you can see. Maximum. This is one edge, this is another edge, this is another edge, this is another edge. So I already told the space complexity of any recursion program will be depends upon what is the height of the recursion tree, friends. So the height of the recursion tree will be 4 if n is equal to 4, though the space will be order of n. Now the time complexity will be depends upon number of function calls. Time complexity will be depends upon number of function calls. So if let us analyze here. So some pattern you can observe here, friends. So what is that pattern is? So first let us start with a small input. If n is equal to 1, total how many function calls you are getting? So when n is equal to 1, approximately how many function calls we are getting? Including f of 1, we have to take, friends. See, print n you can ignore, friends. So if n is equal to 1, including that function call, total 3 function calls you are getting. Approximately I am writing, including that function call. Okay, if n is equal to 2, including that function call, total how many? Including that, whatever the function call of all the f of 1, see, all the f of 1 function calls plus f of 1 function calls plus another 3, friends. If you call f of 2, first of all, f of 1 got, under f of 1, how many? 3 function calls. You already know. This is the answer for f of 1 function call. Okay. And this is the answer for f of 2 function calls. So 3 plus 1 plus 3, which is nothing but 7. Now, if we call f of 3, so you will get some pattern here. If you call f of 3, which means n is equal to 3, let's see how many function calls are there. So if you see f of 3, all the f of 2 function calls plus including that function call plus another all f of 2 function calls. So can I write this is 7 plus 1 plus 7? Yes, you can write it. So which is nothing but 15. So 15. Now, similarly, if you cover f of 4 total function calls, which is n is equal to 4, then you can find easily some pattern here, friends. What is that pattern? 15 plus 1 plus 15. So which is nothing but 31. Okay. So here there is some pattern is there. So n is equal to 1. I am getting its value as 3. If n is equal to 2, I am getting some value as 7. If n is equal to 3, I am getting a value as 15. If n is equal to 4, I am getting a value as 31. So the overall time complexity will be, so it will be fit under this formula. That formula will be 2 power n plus 1 minus 1. So if you want, you can substitute, friends. If you want, you can substitute also here. If you keep in n place of n, if you keep 1, so 2 square minus 1, so 4 minus 3. This is nothing but 4 minus 3. This is nothing but not 4 minus 3, 4 minus 1. 4 minus 1. This is nothing but 8 minus 1. This is 16 minus 1. This is 32 minus 1. Therefore, this is 32 minus 1, which is 2 power 5. N is for 2 power 5. So the formula will be 2 power n plus 1 minus 1. So in terms of big O, we can represent it as order of 2 power n. So if you know about big O, you can able to understand, friends. If you don't know about big O, just listen that this is how it will happen. Okay, so this is how we are going to find out the time complexity. Okay, so simple. Space complexity will be height of the tree. Space complexity will be order of 2 power n. Okay, depends upon the number of function calls. Okay, so number of function calls, right? Okay, now, yeah, it is also called as an exponential, friends. It is also called as an exponential time complexity. Okay, so now let me go to the next question. Let me go to the next question. Okay, so this is a good question. So kindly see everyone here. Okay, so next. Now read this question. What is the return value of the following code when it is getting called with honey of 4? Honey of 4. Now, so here I am calling that function 4, friends. Honey. So honey, which means control will comes here. Since I am calling honey, right? Therefore, I am going to write honey of 4. Listen carefully. Listen carefully. Okay. Honey of 4 I am calling. So here x value will be 4. And this is x. I'm just explaining this code, try running this. Okay. Is x is less than 1? No. No, right? Then else these statements are going to get executed. So what are the two statements? So I'm going to draw return. So return honey of x minus 1. So then honey of x value will be 4, x minus 1 will be 3 plus bunny of x. So, but once if honey 3 completes, then only control will execute the bunny of x. Till then, it won't touch, friends. That is the recursion follow. Okay, that is how the recursion will work. Okay. Honey of 4. Now, next return, you are calling honey of 3. Honey of 3. So, which means now this is the x value. Again, you are calling honey of 3. So, x is less than 1. No. Then again, return these two statements will be work, which is return honey of x minus 1, which means honey of 2 plus bunny of x will be called. But bunny of x, when it will executed, once if honey of 2 is complete. Okay. Then again, you are calling honey of 2. Again, x is not less than 1. So it will call bunny of these two friends again. So when honey of 2 happen, so what will happen? So the x value will be 2 again. So first return honey of x minus 1, which means honey of 1 plus this bunny of x will be called. Okay. So now again you are calling honey of 1. So is 1 is less than 1? No. Then again else condition will get executed. Now else condition is containing two terms. One is honey of x minus 1, which means return honey of x minus 1 will be 0 plus bunny of x will be called. Okay. Now interesting. Observe here. So now you are calling honey of x, which will be 0. Now is 0 is less than 1? True. Then what will happen? It will return that value 1. Therefore, output of honey of 0 will be 1. Output of honey of 0 will be 1, friends. Once if honey 0 completed, then bunny of x will be executed. Now, what is bunny of x? X will ask to the parent. Parent is saying that x is equal to 1. Now, bunny of 1 will be called. Interesting. So, from here, we are coming to bunny. Now, bunny is containing a value 1. Okay. Now, is 1 is less than 2? Correct. Now, 1 is less than 2. Therefore, it will return 1. Now, bunny of 1 will be 1. So, honey of 0 completed. Bunny of 1 is also completed. Then addition operation will happen. So, honey of 0, 1. Bunny of 1 will be 1. 1 plus 1, 2. And the 2 is going to return. To whom it will return? whoever called this function. Who called this function? Honey of 1 is called. Therefore, honey of 1 is going to get a value 2. Okay. Now, honey of 1 value will be 2, friends. Okay. Then bunny of x will be called, because now honey of 1 completed. Then bunny of x. What is this x? Ask to parent. So parent is saying that x is 2. Now bunny of 2 will be called. Okay. Now it will check again. Is x is less than 2? No. Then control will execute else. So else statement is containing 2 things, friends. That is, again you are calling honey of x minus 1. What is x value? 2. 2 minus 1, which will be 1. So honey of 1 will be called plus. So it is completely written. So written honey of x minus 1, which means honey of 1, x minus 1, 2 minus 1, 1 plus x divided by 2. But x divided by 2 will not going to get executed now. First, honey of 1 has to compute. Friends, you know already honey of 1, because sometime back only we have computed. Therefore, it will directly replace this value as 2. Since I know my value, why should I do the time waste? Correct now. Therefore, directly honey of 1 will be replaced by 2. Now, x divided by 2. What is x? X is 2. So 2 divided by 2. 2 divided by 2, which will be nothing but 1. Okay, so this will be 1. Now, this is done. This is done. Then 2 plus 1, that will be 3. And the 3 will be returned. To whom it will return? Whoever called this function. So, bunny of 2 called now. So, finally, bunny of 2 is going to become a 3. Okay. Honey of 1 done. Bunny of 2 done, which is 2. This is 3. 2 plus 3, that will be 5. And that 5 will be returned. To whom it will return? To honey of 2, we are going to return. That is 2 plus 3 will be 5. Therefore, now honey of 2 will be 5 plus again bunny of x. X will be 3. So it will be replaced by 3. Now bunny of 3. So friends, again control will call. Comes to bunny of x. So which will be 3. Now again, is 3 is less than 2? No. Then again it will call return honey of x minus 1. So x is already 3. So 3 minus 3, which will be 2, plus x divided by 2. So x divided by 2. So friends, first honey of 2 will be completed. You know already honey of 2 whose value will be 5. Then now x will be replaced by 3. 3 divided by 2. Assume this is the floor division. Okay. So then 3 divided by 2, it will become 1, friends. So you have to take the floor value. Okay. Assume it is a floor division. Then 5 plus 1, which will be 6. Now bunny of 3 is going to get a value 6. 100 plus 6, that will be 11, and that 11 will be returned to honey of 3. Okay, so honey of 3 is going to get a value 11, friends. Okay, 11 plus again bunny of x. X is value will be 4. Now bunny of 4 will be called. Bunny of 4 will be called. What is the output? So return honey of x minus 1, which means honey of 3 plus bunny of x divided by 2. So which will be 4 divided by 2. Okay, you know already honey of 3 value, which is 11. Then 4 divided by 2. So it is not bunny, friends. It is simply x divided by 2. It is simply x divided by 2. Okay, so x value will be 4. So 4 divided by 2, it is going to become 1. Now 11 plus 1, which is nothing but 16. Okay, so 16 plus 11, which will be 27, and that 27 is going to be returned to honey of 4. So finally, honey of 4 is going to get a value 27. So that what is the question? The question is about, okay, any mistake? 4 divided by 2 will be 2. Okay, correct. It's my mistake. So 11 plus 2, I think 13. So this will be 11. 4 divided by 2. So 11 plus 2, which will be 13. 13 plus 11, 24. Correct, friends. Correct. It's my mistake. So the output will be 24. So final output will be the 24. Right? So I hope you understood. From one function, recursion, and again you are going another function. So this is called as a indirect recursion, friends. It is called as a indirect recursion. Okay. This will be called as indirect recursion. Indirect recursion. Okay. Okay, cool. So I hope you understood now. So don't worry, I will share these notes. I will share these notes with you. So later also you can refer this. Okay. Next question. I hope, is it interesting? Solving problems. Right. So I hope I'm drawing. Okay. Cool. Next question. This is interesting. Okay. So now I am giving you to exercise. I'm giving you for the exercise to analyze the time and space complexity. So you people please take pen and paper and on your own try to analyze. So someone asking, sir, why it is called as a indirect recursion? See, from one normally if you see the previous problem, same function, in the same function only calling is happening, friends. Whereas here if you see, from that function you are going to another function and that function is calling this function again. See, if you check here, what is the flow happening? So this is the honey function and this is the bunny function. Okay. Now from honey, you are calling bunny. From honey, if you see, you are calling honey as well. In the honey, you are calling honey, friends. And as well as from honey, you are even calling bunny also. Now what bunny is doing? Bunny is calling honey again. So it is not directly calling. Okay, from bunny, again you are calling honey. So it is called as a indirect recursion. So it's called as a indirect recursion, friends. Okay, honey, bunny, yes, something like that. Okay. So next question. Now we will take this question and we'll take some break. Okay, so we will solve this question and we'll have some break. Cool. Now, let's see, friends. So in the main function, always execution will start from the main function. Doesn't matter whichever the programming language you use. Always execution start from the main method, friends. Okay. In the main method, I have taken one variable called as result. Okay. In that result, I am calling this function fun of 99. So whenever if you call this function fun of 99, immediately control goes to where did you define this function fun of 99? So fun of 99 is defined here. So then immediately control will goes there and its n value will be 99. N value will be 99. Okay. Now fun of 99 is going to get executed for the first time. Now friends, n value will be 99. Okay. Now is n is greater than 100? No, 99 is not greater than 100, right? Therefore, if condition will be false. Then control comes to else case. Now else case, if you see, function inside another function is present. Okay. Here if you see, you are calling fun of, again you are calling fun of n plus 11. Somewhat interesting this is. Now check here. What is happening? So it is saying that return, okay, return fun of n plus 11. You know already n is 99. What is 99 plus 11? Which will be 110, right? So 110. Okay, so first what will happen now? First it should calculate the what is the value of f of 110. Now control goes to n is equal to 1110. Now tell me friends, if I call f of 1110, again it will go inside. So is 1110 is greater than 100? Yes, 1110 is greater than 100. Then what it is going to return? It will return 110 minus 10. So what is 110 minus 10? 110 minus 10 is nothing but 100. Therefore, if you call fun of 110, the output will be 10 and that 10 will be replaced here. Okay, sorry, 100. So f of 110 is nothing but 100, friends. So therefore, so the output of 110, which is 100, will be replaced here. 100 will be replaced here. Then what will happen? Now fun of 100 will be called. Okay. Check this. Now the next time n value will be 100. Okay. Now check, is 100 is greater than 100? No. 100 is not greater than 100. Then control will go, it execute the return statement, friends. Else part. So in else part, what is there again? Return. Same story will repeat. Fun of n plus 11, friends. What is the n value? This time n value will be 100. Okay, here if you can see, n value will be 100, friends. Now 100 plus 11, which will be 111. So therefore now fun of 111 we are going to call. Fun of 111 we are going to call, friends. So 100 is gone. Now we are calling 111. Now when I call 111, which means I want to find out output of f of 111. I want to find out output of f of 111. Now 111, this condition true now. Therefore 111 minus 10. What is the output? 111 minus 10, which is 101. So which is 101. Therefore, so in place of f of 111, I can replace it with 101. Okay, I can replace it with 101. So now again you are calling fun of 101. So friends, now I am calling fun of 101. Let us see what will be the output. What will be the output? If I call fun of 101. Now tell me, friends. So now I am calling this complete function f of 101, friends. Now what is f of 101? 101. Is this condition true? Yes, this condition true. So once if this condition true, what it will return? 101 minus 10, which is nothing but 91. Which is nothing but 91. And so this f of 111. So this f of 111. Okay. So completely it is going to return 91, friends. So from here, control goes to above and it returns that value 91. Okay. So it returns that value 91. So this 91 is about what? From starting from here to here. Whatever this will be this 91. And that 91 will be written because return statement is present now. That will be written to whom? Whoever called that function. Whoever called that function, for that function, 91 is going to get written, friends. Therefore, this fellow called now completely. Correct? This fellow called right completely. So this guy is going to receive a value called as 91. And that 91 will be written to whom? Whoever called that. Who called? F of 99 called. Therefore, that guy, we are going to return that value as 91. 91. Now, finally, f of 99 is going to get that output as 91. Now, who called this function? Here you have called this function. So finally, to that fellow, this 91 is going to return. So this 91 is going to return to this fellow. And this fellow, what he is doing? He is storing this 91 inside this result. And finally, I am printing that result. Therefore, here the output will be 91, friends. Output will be 91. Correct? Got it? So from where did we started? How function call is happening? Next, where it is going? And finally, how it is printing that output. Right. So this is what it is happening, friends. Cool. Right. So now we'll take a break. So it's 8:15. So we'll take small break only. Small break only we will take. So it's 8:14 now. So we will meet at 8:20. So friends, we will meet at 8:20. Okay. So please everyone come to 8:20. We'll prepare. Meanwhile, you can solve this question. Meanwhile, you can solve this question if you want to solve. Okay. Let me pause the recording for some time. I will start again once if I start the class. Okay. Cool. Okay, so we'll start, right? So let me start the recording. So is my voice is fine? Okay, cool. So I gave one question, right, to solve this. So what is the answer, friends, this question? I think some students are all typing 12 or 24. Okay. Yeah, check this. So as I told, always the execution will start from the main method. Okay, so from main only, always execution will start. So I'm calling print fun of 4 comma 3. So friends, whenever if I call 4 comma 3, immediately control goes, where did I define this function fun? So here I have defined, right? So immediately control from here to here, it will goes. Okay. So I am writing here fun of 4 comma 3. So let's say this is 4 comma 3. Okay, so this is A and this is B. This is A and okay, this is B. Now A value will be 4 and B value will be 3. Okay, so is B is equal to 0? No. But is B is modulus 2 is equal to 0? No. No, because B is not even. Then control will execute the else. So in else, what is the statement that is present here? Else. Double voice. Is my voice is coming? It's fine, right? Okay. Now 4 comma 3, friends. So 4 comma 3, right? Now else part is going to get executed. So return. Again, you are calling fun of. A plus A, which is 2 into A. So A is already 4. 4 plus 4 is 8. Comma B divided by 2. Remember, friend, this is floor. Floor division you have to take. Floor division. So you should not take the points. Okay. So which means 3 divided by 2, which is nothing but 1. 1.5 normally, but you have to take 1. Plus, once if this is completed, then only A value will be replaced. Till then, it won't touch, friends. Okay. Now you are calling again fun of 8 comma 1. Fun of 8 comma 1. So this is the A value and this is the B value. Next time. Now again, is B is equal to 0? No. Is B is divided by equal to 0? No. Then else part is going to get executed again. So which means return fun of A plus A, which means 8 plus 8, which is 16, comma B divided by 2. 1 divided by 2 will be 0 plus A. So now again you are calling this value, friends, A comma B. Now this time if you check 16 comma 0. So A value will be 16 and B is equal to 0. Now is B is equal to 0? True, right? Correct. Therefore, it will try to return that 0. So it will return that 0, friends. Now I'm started from here and I came and I'm again going back. So it will try to return that output as 0. Okay. Plus A. What is this A? It will ask to its parent. Parent is saying that A is equal to 8. Now it will replace its A value with 8. So now this output will be 0 plus 8. So that 0 plus 8 will be added. And finally, that 8 will be returned. To whom it will return? To the caller function it is going to return, friends. So now f of 8 comma 1 is going to get a value 8. Now 8 plus A. What is A value? Asked to parent. Parent says A is equal to 4. 8 plus 4, which will be 12. And that 12 will be returned to the caller function. Now it is going to get a value 12 as the answer. Finally, this function will return 12. To whom it will return? Wherever you called. So I called here. So here I am going to return that value 12. So I am going to return that value 12. And finally, that 12 will be printed in the output. Okay, so that is what happened, friends. So finally, that 12 will be printed in the output. Okay, next. Cool. So I guess this problem you can solve. I'm leaving it out for you. I'm leaving this question for you, friends. So you can solve it little later. I'm going to the next question because this question is same as previous question only. So I'm going to the next question. Okay. Now take this question. So this question, now you take 2 minutes of time, or 2 to 3 minutes of time, solve and tell me what is that output. So far I have explained so many questions. Now you take 2-3 minutes and what is the answer? First try for yourself. Please try for some time. See, those who want to write, just wait for at the end, I am going to release these notes, friends. This recording will be available in the YouTube. So this will be available in the YouTube. Don't worry. Don't worry. Okay. So in the Masai YouTube channel, you can check this video. This video will be available. Okay. Now solve this question. Someone asking, sir, when it will be available? Immediately. Once if class ends, immediately it will be available. So how many stars it is printed? That is the question. Okay, so 1 more minute is left. Someone saying 3, someone saying 6. Okay. In the same way, what I have told, try to apply, friends. Okay. And this is floor division. Okay. That is floor division. Yeah, so I'll start on explanation, friends. Now, please, everyone, concentrate here. Okay. So someone asking, sir, why you haven't written that stop function? Just see, you will get a clarity. So as I told, always execution start from the main method. So immediately control from here, it will go wherever you define that function. So here I have defined, right? So control will goes there, function fun with the value 7. With the value 7, friends. Okay. Now, first time it will get a value as 7. Okay. Is if condition true? Yes. Because a is greater than 1. Yes, it is correct. Then these two functions are going to get executed. Line number 1 and line number 2. So let me draw here. So line number 1 and line number 2. So what is the line number 1? Again, you are calling fun of, this is a. Okay, 7 divided by 2 will be 3, friends, not 3.5. Okay, so it should take the floor division. Now, again, what is the second statement? F of a divided by 2. So this time it won't even touch. So it will be a divided by 2 only. Okay, na? Once it is done, can you tell me, is this print is going to get executed or not? This statement, does it execute it? Of course, it will execute, friends. You might thinking that it will not execute. It will execute. If irrespective of this if condition, whether it will be true or false, always it is going to get executed. In case if this print star will be present inside that else statement, then this will not going to get executed. But this print statement is not present inside that else block. Therefore, no matter whether if condition will be true or false, always print star is going to get executed. Okay, so I think some of might have done that mistake. So always this print star is going to get executed, friends. But when it will execute this print star, not now, not now. this has to complete, this has to complete, then this print star will be executed. Okay, now? Now let's call this f of 3 again. Then a value will be 3. Okay. So again, this condition will be true. Then these two statements are going to get executed. So line number 1, line number 2. Once these two are done, then next, okay, so this print star will be executed. So this also going to get executed. Print star, right? Now, first line number 1. So what we are calling, friends, line number 1. So again, fun of, this is a value, right? 3 divided by 2, which will be 1. Okay, so first I'm calling fun of 1. Now, if I call this fun of 1, is this condition true? No, this condition will be failed. Condition will be failed, friends. Now, but this print star will execute? Yes, of course it will execute, because it is not inside the if block. Therefore, for this F1, what will happen? Just it will simply print only 1 star. That's it. It will print only 1 star, friends. Okay, 1 star will be printed. Next, if it is completed, control will execute the line number 2. What is that line number 2? Again, fun of a divided by 2, which means now again you are calling fun of 1. So one more time you are calling fun of 1. Now again this fun of 1. So one more time star will be printed. Yes, of course. This fun of 1 also, print star will going to get executed. Right. This is also completed. Then this is another print star. Therefore, if you see carefully, friends, under this f of 3, total, how many stars are there? Under this f of 3, 3 stars are there. So if you call f of 3, it will give output as 3 stars. 3 stars. Okay, that is fine. Now this is also completed, friends. Now tell me again, now second statement, f of a by 2. What is a value? 7 by 2. It will be 3. Okay, now overall you are calling again f of 3. Now do I require to do it again, whole this process? Not required, because I know already when I call f of 3, I will get 3 stars. Therefore, I no need to repeat again. Therefore, here I will get 3 stars. And already f of 3 stars you are getting. Now another star, and then this function is completed. So overall, how many stars you are getting? First 3 stars, then another 3 stars, and then another 1. So friends, overall 7 stars it will be printed. Overall 7 stars it will be printed, friends. So I hope is this clear? I think someone is asking, it will run in an infinite loop. No, friends, it will not run in an infinite loop. It will not run in an infinite loop, friends. Okay, so it will be clear. It will be stopped because nothing else not to execute it. Cool. Next question. So what about time and space complexity? So of course, space complexity will be order of n. So nothing. Order of n will be the space complexity. What about time complexity? Time complexity. For 7, if you call 7, how many stars it is printing? 7 stars it is printing. No. We have to see how many function calls we have to see. Number of function calls we have to see. Let us see, friends. First, for f of 1, try to count it. Try to count. Okay, so sorry. Space complexity will be not order of n, friends. Space complexity will not be order of n. When you call f of 7, control is going to 7 divided by 2, 3. Then control is going till 1, and the program you are stopping. So starting from n, next it is going to n by 2. After that it is going to n by 4. After that it is going to n by 8. So every time you are divided by 2, the moment when you reaches to 1, you are stopping, friends. So what is the series of this expression? So we have studied when we see about time complexity, we have seen what is this series, friends? It is log n series. Therefore, space complexity will be order of log n. Order of log n, friends. Now, what about time complexity? What about time complexity? What about time complexity? So try to count number of function calls. If you call f of 1, only one function call. If you call f of 3, including that f of 1 plus f of 1 plus f of 3, 3 function calls. Next, if you call f of 7, already here 3 function calls, another 3 function calls plus 1. So whatever that n value, so it is proportional to those many function calls, friends. Therefore, the time complexity will be order of n. Order of n. So it is proportional to the n value. Okay. If n is equal to 1, only one function call. If n is equal to 3, already one function call, another function call, including that 3. If f of 7, 3 function calls for f of 3, another 3 function calls for f of 3 plus including that 1. So 3 plus 3 plus 1. So overall proportional to n, friends. Therefore, the time complexity will be order of n, space complexity will be order of log n. Okay, if n is equal to 8, what? So same way, try to analyze, you will get it. Same way, try to analyze it, friends, you will get it. Okay, next. So how many questions are there? So 3 more questions are there. Then we will start writing the problems. Okay. Now take this question. Now it's a good question. So you might take maybe 3 minutes of time. So take 3 minutes and solve it properly and tell me, friends. Later I will explain that answer. So it was written in a C programming language. So if you know C programming, it is okay. Otherwise, you can start. First, observe the code. First, try to observe the code, friends, like what they are trying to say. And then we will see the solution. Okay. So come on, everyone, start solving it. Okay, so let me explain. Now check this, friends. It is one of the previous year gate question. So, purely conceptual based this question is. Cool. What they're asking here. So always, as I told, control calling start from the main function onwards. So here I'm called as calc with the value 4,81. Then immediately control will goes because here you have defined this function, right? So control will goes there. Friends, here I have defined one variable. This is called as a global variable. So the meaning of global variable is, so which will be accessed throughout the program. So wherever you are there, you can easily access this variable, friends. That is the definition of the global variable. Okay. So I will define one variable called as counter here. And whose value is 0. Whose value is 0. Okay. Now I'm starting calc. Okay. I'm writing it as C. Calc I have. Okay. So let me write it. CAL. cal C. Okay. So A value, B value, which is 4, 81. 4, 81. Now this is A and this is B. This is A and B, friends. Now here I have defined one local variable. This is called as a local variable, will be local to this function. So I have defined one variable called as C. And next step is counter plus plus, which means it is called as a post increment. So counter value will be incremented by 1. Okay. Now next statement, if B is equal to 3, then return A cube, A into A. Now I'm going to check, is B is equal to 3? No, right? B is 81, friends. So therefore, this condition will be false. Then control will enter inside this else block. Now else block is containing 2 lines, line number 1 and line number 2. Now first let me execute line number 1 and then I will see the line number 2. Okay. What is line number 1? So line number 1 is C is equal to, what is this C? This C, whatever you have defined. I am calling again this cal C of A comma B divided by 3. What is A value? A value will be 4 and B divided by 3. 81 if I divided by 3, which is nothing but 27. Once if line number 1 completed, then it will return. So return whatever this C value that you got it, right? That return C into C into C. We will talk about later. But now you need to call this cal C of 4, 27. So now again I am calling, friends. So 4, 27. Now this will be A and this will be B. Now I am checking. Another again, every time you are going to declare one C value, then counter plus plus, which means now counter value will be updated by 2. And is B is equal to 3? No. Then else these 2 statements are going to get executed again. Okay. What is the first statement? The first statement is nothing but C is equal to cal C of, okay, cal C of, I'm calling again. So cal C, I'm writing CAL. So cal C of A comma, what is A value? Which will be 4. This is floor division. 27 if I divided by 3, it will become 9. It will become 9. And then second, there is a statement called as return C into C into C. So let's talk about later. What is this C value? Right now, we won't worry. Now again, I'm calling cal C of 4, 9, friends. So now again, another C will be created and counter plus plus. So counter is going to become 3. And is B is equal to 3? No. Then again, else these 2 statements are going to get executed again. These two statements are going to execute it again. Okay. So now cal C of 4, 9. This is A and this is B. So again, else case, first line number 1. Cal C of, again, C is equal to cal C of A comma. What is A value? 4. And what is B divided by 3? Which is 3. 4, 3 will be called. Once it is done, then return this C into C into C is going to get executed. Okay. Now again, I am calling cal C of 4, 3, friends. So this is A and this is B. Now again, when you call 4, 3, a C will be declared. Counter plus plus will happen. So as of now, counter value will be 4. Now is B is equal to 3? Correct. Then what will happen? So return A into A. So A cube. So when you call this function, it is going to return A into A. So what is A into A, friends? So which is 64. And that 64 will be present inside this C. So once if it is completed, those C value is going to get vanished. Friends. Okay. Okay, this C. And that C is going to get updated. So it is returning, right? So whatever that C value, which you are returning now. So here you are returning, right? This 64 is going to return to this function. Now this function is going to get a value of 64. So which will be present here. So this function will return 64. That 64 will be coming here. Okay, completed. Then all the activation record will be deleted. Now I am returning C into C into C. So what it is going to return, friends? 64 whole cube. 64 into 64 into 64 will be returned. Whatever that value will be present inside this C. And finally, that C we are going to return. So here we are going to return that 64 cube. Then 64 cube, 64 cube, 64 cube. Whatever that value will be written. And again, whatever that value will be written. And finally, control goes there. But here, that value is not important for us. Why? We are not storing anything here. What we require counter value. We require counter value, friends. Finally, if you check, they are printing that counter value. Therefore, this written value is not important for us. Correct, na? So now finally, what is the counter value? 4. So the output will be 4. Very good question. Very good question, friends. So that's why you have to give importance to the reading the question. So always remember, importance should be given to the for reading, friends. So once you understand, that is good. Okay. So you have to read the question always, what they are asking. What they are asking. Okay. Cool. So we'll go to the next question. This is interesting question. So which I have framed before coming to this class, I have framed this question. So what they're asking here is, what is the return value of the function? And I am passing fun of n comma n, friends. And what is this n value? You take any some value will be greater than or equal to 1. N, some n value you can take, but this a value, b value, both are same. I am passing. Both are same. I am passing. Maybe if you take n is equal to, let's say 3. If you take n is equal to 3, then which is nothing but fun of 3 comma 3. So you have to compute fun of 3 comma 3, say the output. Then next, if you take n is equal to 4 and compute fun of 4 comma 4 and say the output. Similarly, you take n is equal to 5. Okay. And then compare fun of 5 comma 5. And so you will get some pattern actually. Based on that pattern, you need to design some formula. Therefore, here I have written, please give answer also in terms of n. So friends, in terms of n, I am expecting the answer. Now take pen and paper and try what will be the output of this question. Again, take 2 minutes and solve this question. What will be the answer? Answer also in terms of n you have to say. Okay. So I am getting a couple of answers. Yeah, let me explain, friends. Let me explain. So let me take fun of 4 comma 4. If I take fun of 4 comma 4 and let us see what is its output. What is its output? If I take n value as 4. So if I take n is equal to 4, so a value will be 4, b is also 4. B is also 4. Now observe carefully. Is a is less than or equal to 0? No. Is b is less than or equal to 0? No. Then I am calling x is equal to something, y is equal to something. So friends, I am calling here first x is equal to, I am calling fun of a minus b. A minus b, 4 minus 4, which will be 0, comma, a plus b, that is 4 plus 4, which will be 8, I am calling. Once it is completed, then y is equal to again fun of whatever this a plus b, comma, a minus b will be executed. If this is also completed, finally, I am going to return that x plus y. I will return that x plus y. Okay. Now check this. First, I am calling fun of 0, comma 8. Now this is a and this is b. Okay, now check, is a is equal to 0? No. But is b is equal to 0? Yes. Then I am returning the a value, which means here I am returning this value called as 8. What is this 8? This 8 is nothing but 4 plus 4. This 8 is nothing but 4 plus 4. 4 plus 4. Okay. Yeah, a is equal to 0, return b. Okay, yes, this is true, friends. This is true. Yes. Okay. Now again, I am calling y is equal to a plus b comma a minus b. So what is a plus b? A plus b is nothing but 8. What is a minus b? This will be 0. So now I am calling again 8 comma 0. So when I call again 8 comma 0, this is a value and this is b value. Now b is less than or equal to 0. Therefore, I will return a. I'm going to return this 8. So what is this 8, friends? This 8 is nothing but again 4 plus 4. 4 plus 4. So once it is done, 4 plus 4, 8. So another 4 plus 4, 8. So finally, x plus y, 16 I am going to return. So finally, this function is going to get output as 16. Output as 16. Okay, so what is happening here? If you check, what is happening here? If you want to take 5 comma 5 also, and then start checking. Let us take 5 comma 5. 5 comma 5. So roughly, I will explain. If you take 5 comma 5, what will happen? What is the output, friends, if I take 5 comma 5? Okay, let's try to see here. So this is A, this is B. Roughly, I will explain. So this false. So this condition false. Then you check here. X is equal to fun of A minus B. 0 comma 5 plus 5, which will be 10. 10. And when you call this, it will return the 10. Similarly, y is equal to fun of again 5 plus 5, which will be 10 comma 0. So when you call this, you are going to get a value 10. Now 10 plus 10, so which will be 20. So what is happening here? First, whatever that n value that you have taken. So here you are doing 5 plus 5. Here again you are doing 5 plus 5. 5 plus 5. Okay, so this is n value. So 2n plus 2n, which will be nothing but 4n. So the answer will be 4 into n, friends. So whatever the value that you take, which is getting multiplied by 4. So same n value you are adding 4 times. So n plus n plus n plus n. So the answer will be 4n here. Assume always this true when n is always greater than or equal to 1. N is greater than or equal to 1. So return x plus y. Yes. Clear? It is returning now finally x plus y. So whatever that x that you have stored, that is returning. So 4 into n is the answer, friends. Okay. We'll go to the next question. So this is also important question, friends. Kindly see this. Okay, so this I will only explain because this is somewhat related to backtracking. Okay, the question is, what is the return value of fun of 4? Now same code, how we are going to explain, how we are going to solve this. So first I am calling fun of 4. Many people may find difficulty while solving here. So kindly observe. So these kind of models, usually we found out when you are solving backtracking problems. Okay. So n is equal to 4. I have taken one variable x, which is also equal to 1. Okay. And some k value is there. If n is equal to 1, I am going to return x, but that is not true. Then I am running a for loop. And this for loop, how many times it is going to run? Starting from k is equal to 1 to k less than n. So which means this for loop is going to run first k is equal to 1, condition true. Then k is equal to 2, condition true. Then k is equal to 3 also, condition true. So friends, first time, if k is equal to 1, this condition will be true because 1 is less than 4. Then k is equal to 2, then also this condition true. Then k is equal to 3 also, this condition true. But the k becomes 4, this condition false. So this loop is not going to get executed. Okay. Once if this for loop is completed, then finally they are returning the value of x. So this is the last step. What is the last step? After completion of this for loop, we have to return the whatever that x value. That is the final step, friends. Okay, first let's see what will happen when k is equal to 1. So it will enter inside this for loop. Okay, listen everyone carefully. So everyone carefully listen, friends. So x is equal to x plus what is already the x value available? 1 plus I am calling fun of k, which means fun of 1 into fun of n minus k. So fun of what is n value? That will be 4. What is 4 minus k, which will be 3, but that will be executed later. Why that will be executed later? Because first you have to complete f of 1. Then what will happen, friends? Control will leave this f of 1. So it will comes out. So we are going to execute f of 1 separately. So when you call f of 1, now here n value will be 1. Okay. So x is equal to 1. Whenever if n is equal to 1. So whatever that x value that you have defined, it is going to return, friends. Therefore, f of 1 value will be 1. So directly it will return f of 1, 1. So I can substitute here in place of f of 1. I can substitute this value is nothing but 1. Okay. Now I have to compute what is n minus k. So n value will be 4. 4 minus 1, 3. And it will be now replaced by 3 here. Therefore, now I have to compute what is the value of f of 3. So friends, I will write it separately, f of 3. So if I write here, it will become clumsy. So I am writing it separately for f of 3. F of 3. So again, now I am calling n value with f of 3. So now this is 3. Okay, now I am going to define one x value, which is nothing but 1. 1. Now is n is equal to 1? If yes, it will return x, but false now. Then again control enter into this for loop starting from 1, k less than n, which means it will run for 2 times, friends. So first k is equal to 1, it will run, and then k is equal to 2 also it is going to run. So it will run only 2 times. Okay, so first k is equal to 1, it will run. Then k is equal to 2, it will run. After that, once if this loop is completed, whatever that return value of x, it is going to return. So once if this for loop complete, then finally it will return that x value. Okay, it will return that x value to the caller function. Friends. Okay, so first let's execute what will happen if x is equal to 1. Now check here, if x is equal to k is equal to 1, it is going inside. So x is equal to x plus. So x is equal to what is the value of x? This one, friends. So 1 plus fun of k. What is k value? K value is nothing but 1. So fun of 1 into fun of n minus k. You know already fun of 1 value which we have computed. So I'm directly substituting. Then next fun of n minus k. That is n is 3, k will be 1. So 3 minus 1, which will be 2. So you want to compute the fun of 2 value, friends. So for that, what I'll do, I'll take it separately and I'll explain here. So I'm computing now fun of 2 value. Fun of 2 value. Okay. So now again, n is equal to 2, right? Now, so I'm declaring one variable x is equal to 1. Okay. Now is n is equal to 1? No. Now n value will be 2, friends, right? Now k, how many times this loop will run? Only 1 time only, because when k becomes 2, loop will be failed. So it will return only 1 time, that is k is equal to 1. So when k is equal to 1, it will go inside. So what I have written here, x is equal to x plus, x value will be 1 plus fun of k. What is the k value? Which will be 1. So fun of 1 into fun of n minus k. You know already fun of 1 value, that is 1, which we have computed already. So 1 into fun of n minus k. So n value will be 2 that we are passing. So 2 minus 1, which will be 1. So, and you know already again f of 1 will be 1. So 1 into 1, which is nothing but 1. Okay, plus 1. That will be 2. So x value will be updated by 2. So once if this for loop will over, it should supposed to return that x value now. Okay, so it will return x. What is the x value? X is equal to 2, and the 2 will be written. So therefore, f of 2 will be 2, friends. So I can substitute directly. F of 2 is equal to 2. Now what will happen? 1 into 2, which will be nothing but 2 plus 1, which is 3, and 3 will be updated inside this x. The 3 will be updated inside this x. Okay, k is equal to 1 completed. Now k is equal to 2 will be executed, right? So what is k is equal to 2? What will happen? Again, same statement is going to repeat. X is equal to x plus. This time what will be the x? Updated value we have to take. That will be 3 plus fun of k, which is nothing but fun of 2. You know already fun of 2 value. This is nothing but 2. So fun of 2 value will be 2 into fun of n minus k. N value will be 3. 3 minus 2, which will be 1. Fun of n minus k. So fun of 1. You know already this will be 1. So 2 into 1, which will be 2 plus 3. That will be 5. And that 5 will be updated inside that x. Okay, so 2 plus 3, yes, 5 will be updated inside that x. And whatever that x value that we are going to return, friends. So that will be 5. Therefore, f of 3, finally, its value will be 5. And that f of 3 will be written here because this fellow called, right? So it is going to return 5. Now 1 into 5, which will be nothing but 5 plus 1, which is 6. And that 6 will be updated inside that x. Therefore, k is equal to 1 completed. But k is equal to 2 also pending. So again, we have to execute same thing. X is equal to x plus. X is 6 plus fun of k. Same statement, friends. Fun of k is equal to 2. You know already fun of 2 value, which is nothing but 2 into fun of n minus k. What is n value? 4. 4 minus 2, which will be 2. So again, this is 2. So 2 into 2, which will be 4. 4 plus 6, that will be 10. 10 will be updated here. Next, k is equal to 3. So x is equal to x plus, which is 10. 10 plus fun of k, which is fun of 3. You know already fun of 3 value, which is nothing but 5. 5 into fun of n minus k. That is n minus k. Again, fun of 1. What is fun of 1? Which will be 1. So 5 into 1, that will be 5 plus 10, which is 15. So x value will be updated by 15. K is equal to 3 also completed, and it will return that x. What is the final updated x? 15. To whom it will return? To wherever we are calling. So here the finally output of is 15, friends. So this is how it will work. So complicated, but yeah, of course. But see, backtracking problems are complicated only. This is just as an example for backtracking, friends. This is just as an example for backtracking. So always, obviously, backtracking problems are complicated, but of course, you got it right. I mean, what is happening, like how the trees I have drawn. So always this method you follow, friends. Always you follow this method, it will be easy. Okay. So next, now let us take a. As of now, we have seen the problems based on numbers. Now let us see the problems based on arrays. We'll see one problem, then we will start writing the code. We'll start writing that code. Okay. Now see carefully here this question. Sir, what is the return value of the following function if you pass below array as an input? So if you pass below array, which is already given as an input, what is the output that is going to return is the question. Okay. Now here they are passing input array, friends, and its size. Size will be 5, and they are passing that input array. Okay. Cool. Now is n is equal to 0, we are going to return 0, but that is not true now. So here if you see, I am calling fun of the input array, comma its size. So size will be 5. Now is n is equal to 0, return 0, but that is not true. Then else return, I am calling again fun of input array, comma 4. N, this is n value, friends. Okay, once it is done, then I will substitute a of n minus 1. So when you are going to substitute, not now, first you need to finish f of a comma 4. Got it? So next control will be calling. So f of, so return. So again, this n value will be not equal to 0. Na? Therefore, it will call a comma 3. Once it is done, then you have to replace this with n minus 1. N minus 1. Okay. Now you are calling this again. This is the n value. Now again, n is not equal to 0. So it will call again return fun of a comma n minus 1, friends. Okay. So which will become to Once it is completed, then you have to write array of n minus 1. But as of now, you should not supposed to touch this because recursion call has to be complete first. Now again, when you are calling, this is the n value. So again, n is not 0. So again, you write return f of a comma n minus 1, which will be 1, plus array of n minus 1. N minus 1. So again, this is the n value. Again, n is not equal to 0. So I am calling again return f of a comma n minus 1, which will be 0, plus a of n minus 1. N minus 1. Okay. Now it will be interesting, friends. Now n value will be 0. So the moment whenever n value will be 0, I am going to return 0. So this function is going to get a value 0 plus a of n minus 1. What is n value? N value, it will ask the parent saying that n is 1. So n place of 1, if I substitute 1 minus 1, that is 0. So what is array of 0? Array of 0 will be 1, and that 1 will be replaced. So array of 0 will be 1 plus 0. So that will be 1. So this function is going to receive a value 1. A of n minus 1, n is 2. So 2 minus 1, which will be 1. So array of 1 is 2. So 2 plus 1, that will be 3. So this function will receive 3. So n value will be 3. 3 minus 1, which will be 2. Array of 2 will be 3. So 3 plus 3, that will be 6. Now here n is equal to 4. So 4 minus 1, 3. Array of 3 will be 4. So 4 plus 6, 10. 10, and n value will be 4. 5. 5 minus 1 will be 4. Array of 4 will be 5. So 5 plus 10 will be 15. So finally, this function is going to return that value 15. So basically, what is this function is doing, friends? Simple. It is computing sum of all the array numbers in the array. So that is 1 plus 2 plus 3 plus 4 plus 5. 4 plus 5. So we have seen previously only one number based, like all numbers only, n, okay, a comma b, all a comma b. But now we are bringing arrays also into the recursion. So we are bringing arrays also into the picture. Okay, so these are all related to, given a recursion program tracing. That is part number 1. So if you go back in the beginning, what I have told. So in the beginning, I have told recursion is in 2 steps. That is part 1. Part 1, which is take a recursion program and tell what is that output. So this part is completed. So I am assuming that you got at least basic idea. If any recursion code is given, so I am pretty sure you are going to do the dry run. Tell me, friends. I hope you got that enough confidence. So again, practice these problems. It will be clear. Now, before starting this part 2, so we will take a break. Now after break, it will be much more interesting because that is the real part. That is the real part, friends, which is start writing a recursion program. That is most important thing. Okay, so let's take a break. So we will meet at sharp 9:15. So we will meet sharp 9:15. Please don't ask 10 minutes break, okay? Because more things to cover. All right, so we will start at 9:15, friends. Yeah, let me stop the recording also. Yeah, so very short break actually. So really, I'm sorry, to giving only small breaks, but yes. So we'll start. So let me resume the recording. Okay. So friends, as I have already told, so part one, given a recursion program, tracing is done. Now I am pretty sure. So if any recursion program if they give, so practice all these questions, friends, again and again. So I'm damn sure you can solve almost all recursion related questions. Now the second part is much more interesting. That is start writing a recursion programs for some problems. Now it will be very easy. Just to see, just to follow me. I will teach couple of problems. So this is again exercise, so you can solve it little later. I'm going there. Now, before I start writing these programs, so as of now, two types of recursion tracings that we have seen, friends. First we have seen with the numbers. So first we have seen with numbers or integers. Okay, so that will be some number n. Next, we have seen it with the help of arrays also. Only one question we have seen with the array, whose size is also n. So first time, if you check, first with the numbers, if you see, we have started with some value n. Then we have decreased the n value. Okay, so now compared to this n, so initially n value will be big. Okay, and we have reduced that n value to maybe n minus 1 or something like that. So compared to big, so this will be small. Okay, and again we have reduced this value to smaller than that. So like that. So whenever if you reach to either 0 or somewhere, we have stopped. That is what we have done, right? If you see, first function call, we have passed a big value. In the next consecutive or subsequent function calls, we have reduced that n value. So in overall, what I want to say, in the next subsequent function calls, we have reduced the n value. Okay, and we have stopped. Similarly, when you come to array also, so let us say if I have taken one array here, this is the array first. So it is containing some numbers, friends. So let us say 1, 2, 3, 4, okay, 5, 6, some numbers. Let's not worry about all those numbers. 0, 1, 2, 3, let's say 4, 5. Okay, so this is the input array, and here number of elements are 6. So initially when you call, the size of the array will be 6. Next time what you have done, you have actually decreased the size. In the next function call, the array size will be 5 only. 5 array size. In the next function call, what you have done, we have reduced its size and we have called with 4. Okay, so 4. And then next function call, what you have done, you have reduced its array size and you have called with 3. After that, in the next function call, its size will be 2. And then after that next function call, its size is only 1. Okay, so in the next function call, when its size becomes 0, so here its size will be 4. So here its size will be 3. So here the array size will be 2. Here array size will be 1. And the next function call, the array size will be 0. The moment when array size 0. So the moment when array size 0, so we have stopped the program. Correct? So here, if you check, when array size is 0, here, when array size 0, we have returned it. Therefore, whether it can be number or whether it can be array, when you are writing the recursion programs, always start with the bigger value. Or big array, and slowly decrease their size. Decrease the size. slowly decrease the size for next function call, next function calls. That is what actually the recursion, friends. In a simple terminology, recursion is nothing but calling the same function again and again with the reducing the sizes of the input. So first time bigger input, then smaller, then finally it will becoming done. We are stopping that problem. So in simple words, that is actually the recursion. That's it. That is actually the recursion, friends. Okay. So now let us start writing some problems so you will get some clarity. First question. Find the sum of all digits of a given number. Okay. So first find sum of the all digits of a given number, friends, which means if the input is n is equal to 1, 2, 3, 4, 5, 6, then the expected output will be 21. The expected output will be 21, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, how I am going to get this output as 121? So first of all, I am going to start with 1, 2, 3, 4, 5, 6. So here the given value will be n. Okay. Now, out of 1, 2, 3, 4, 5, 6, every time one by one digit I have to take and then I have to call, friends. So now when I call n value as 1, 2, 3, 4, 5, 6, in that I have to take one digit separate. Now, which is the digit easy I can take? Can I take 1 or can I take 6 from this number? Taking 6 will be easy, friends. How? I can write simply n modulus 10. I can write simply n modulus 10 so that I can get this value 6. Okay, that is fine. So you will get a value 6 by taking modulus. Next, once if 6 is gone, the next I have to get 1, 2, 3, 4, 5. How should I get this 1, 2, 3, 4, 5 from 1, 2, 3, 4, 5, 6? I can write simply n divided by 10. If I write n divided by 10, I can get 1, 2, 3, 4, 5. Simple. Okay. And next, same process I will apply, friends. Next time what I will do, I will take the same number and this time I will take, now previously this is the n value. For the next function call, this is the new n value. That is 5 plus 1, 2, 3, 4. Now again, next function call 4 plus 1, 2, 3. Next function call 3 plus 1, 2. And the next function call 2 plus 1. And the next function call 1 plus 0. The moment when n value becomes 0, we will stop. Right. So let us write the same thing here. Now check here. Whatever I explained, I am writing here. Okay. So first, if n value becomes 0, okay, I have to stop my program and I need to return 0. Otherwise, else, what I will do? Simple. I will take return. I'll do n modulus 10 every time plus same function I will call again with reducing its n value. How should I reduce? By divided by 10. Over. Story is. Solution is completed, friends. This is the solution. Just 2-3 lines only, nothing else. Recursion problem, just 2-3 lines only. You need to understand what is the n value, how the function calling is happening. See, how did I able to write this code? Because I have already done enough examples on the recursion and I came to know that how actually the recursion is working. Starting from bigger value, slowly its value is reducing. Slowly reducing its value, friends. Even if array also, if you take first bigger array, then one size we are reducing, then another size we are reducing, then another size we are reducing, like that. Getting? Okay, so one question completed. Now same problem, you please write it in the iterative way. So because now time is not there, friends. So since time is not there, therefore you please write it using iterative way. Okay, so next, second code. Implement the power function. Okay, so how should I implement the power function? Normally, like what is meant by power? 2 power 3, 8, 3 power 4, 81, something like that. Now check this. Now everyone please carefully check this. First, I'll call, this time I will take, let us say, POW of, maybe I will take 2 power 5. So what is the answer, friends? 2 power 5. What is the 2 power 5? 32, right? 2 power 5 is 32. I have to get output 2 power 5 as 32. Okay. I have to get 2 power 5 as 32. So normally, mathematically, 2 power 5, how can I represent? 2 into 2 into 2 into 2 into 2. 2 into 2 into 2 into 2. So here, I will take out these two separately. I will take these two separately. Okay. Now, remaining part, if you observe, so can I write this expression as 2 power 4? Of course, you can write. Of course, you can write, friends. Am I correct? Yeah, 2 into 2 into 2 into 2, which is nothing but 2 power 4. Therefore, power of 2 comma 5 is nothing but 2 into POW of 2 comma 4. POW of 2 comma 4. Now, I want to compute what is the value of POW of 2 comma 4. So, POW of 2 comma 4. So, mathematically, how we will represent POW of 2 comma 4? Same way. 2 into 2 into 2 into 2 into 2. Now, what I can write? I can take these two separate, and this I can write it as 2 power 3. I can write this one as 2 power 3. So, which is nothing but 2 into, can I write this one as POW of 2 comma 3? Yes, you can write it. You can write. Next, again, POW of 2 comma 3. How can I write? So, I'm going little fast. So, POW of 2 comma 3, same way. So, POW of 2 comma 3, I can write something like 2 into 2 into 2 into 2. So, I can take these two separately. Okay, this 2 into 2, I can write it as 2 square. 2 square. So, which is nothing but 2 into POW of 2 comma 2. POW of 2 comma 2. Okay, next, how can I write POW of 2 comma 2? Which is nothing but 2 into 2, I can write, because 2 square is 4, right? I can take these two separately, and I can write this one as 2 power 1. 2 power 1. So, which is nothing but 2 into POW of 2 comma 1. 2 comma 1. So, how can I write POW of 2 comma 1? I'll take it separately. So, POW of 2 comma 1. So, which is nothing but, I can write this value as, same process I'll repeat, 2 into 2 power 0 I can write, because 2 power 0 is 1. So, 1 into 2, ultimately 2 power 1 is 2. Right? So, this is 2 into, I can write this one as POW of 2 comma 0. So, I already know anything power 0 will always 1. Anything power 0 will always 1. Am I correct? Of course. So, this is A, this is B, this is A, B, A, B, this is A, this is B, this is A, this is B. So, whenever if B is becoming 0, I'm stopping the process by returning a value called as 1. Now, see, same thing I'm going to write here. So, whenever if I feel, if B is equal to 0, I'll stop and I'll simply return 1. If that is not the case, else what I will do? I will write return. Here, if you see 2 into 2 into 2 into 2, what does this do? This 2 is nothing but A value, friends. Therefore, return A into, again, I am calling same thing POW of A comma, every time I am decrementing the B value. See, earlier it is 4, then it is 3, then 2, okay, then 1, then 0. So, every time I am decrementing the B value. So, A comma B minus 1. A comma B minus 1. Over. Stories. This is the code for implementing the power function. Friends. Any doubts? See the left hand side. Can we get the pattern of recursion or not? Okay. Now same code you take. Try to find out try to find out POW of 3, 5. So recursion code is already there. Recursion code is already there. So I hope you know how to trace the recursion program. I hope you can trace how to trace the recursion program. Multiple examples we have seen. Now take this code and try to trace this. That is why first in part 1, I have explained about tracing the program. Then in the part 2, I have explained the writing the programs. If I did not tell this part 1, if I tell directly part 2 without doing how to trace, then in your lifetime, you won't understand. That's why properly I followed a order, friends. So first I have taught in detail how to trace it, so that if you write something wrong also, you can able to trace it. Acha, here I am doing something wrong. Sir, here I am doing something wrong. Therefore, you will get to know, okay, what is the mistake you are doing. If you don't know how to trace it, then you can't learn it, friends. Right? So always learn it in a proper way. That is most important. That is most important. Okay. Cool. Next. So next question. Write a program to find the GCD of a 2 numbers using recursion. Now again, we'll make this problem simple. See carefully, everyone. See carefully. GCD of 2 numbers, which means greatest common divisor. So GCD meaning is greatest common divisor. Greatest common divisor. So this is also called as HCF, highest common factor. Both are same, friends. Both are same. Greatest common divisor, or you can even call this as highest common factor. Cool. So how we are going to find out a GCD? So first, let us take 36. First, we'll see how we getting value as 12. Then we will take 60. Now 36, try to do the prime factorization. So prime factorization is nothing but start from 2. 2 into 2, 18, 36, right? 2, 18. 2 into 18 is 36. How can I write 18? I can write 2 into 9. How can I write 9? 3 into 3. So finally, this is the prime factorization of 36. Similarly, I have to write even for 60 also. So how can I write 60? 2 into 30. 30 means 2 into 15. 15 is 3 into 5. 3 into 5. So this is how I am going to write the product of its prime factorization, friends. Yes, this is also completed. Now, after writing product of both factorization, now see the common part between both of that. What is common between both? 2 into 2 into 3 and 2 into 2 into 3 is common for both. So since this is common for both, finally, the HCF is nothing but common thing. 2 into 2 into 3. So which is nothing but 12. So this 12 is the GCD, friends. So this is how actually the GCD we are getting 12 for 36, 60. 36, 60. Okay, cool. But if you remember, in our school days, we have find out GCD in different way. In our school days, I don't know whether you have learned this technique or not in the school days. So I have solved it in this way, friends. So I am going to take 36 here. So I am going to take 60 here. I will check it. So listen carefully. Listen carefully here. So I have taken 36. Then I have taken 60. I will check 36. How many times it will go in 60? One time it will go. One time it will go. 36 times. 36 times. Then I will do the subtraction. If I do the subtraction, it will be 24. It will be 24. Then what I will do? I will bring again 36 here. I will bring again 36 here. Now I will keep on do this division process. So 24, it is also goes one time. 24. Then what is the subtract if I do, what will happen? So which is nothing but 12. 12. Again, I will bring this 24 here. I will bring this 24 again here. How many times it will goes? 2 times. So it will be 24. The remainder will be 0. And again, I will call 12. So whenever, if the remainder becomes 0, whatever this value, whatever this value 12 is going to be the final output. Whenever if this value becomes 0, whenever this value becomes 0, so this is nothing but output, friends. 12. Have you all studied this in your school days? Long back. Long back. You might have studied this concept. Now, I don't know, someone saying yes, someone saying no. Now I will prove that in your childhood only you have learned the recursion. In your school days only you have learned the recursion, but without knowing it. Without knowing, you have already studied the recursion that time. I will prove. Okay. Check this, friends. So every time recursion call is happening here. Let me tell you how recursion call is happening. Check carefully here. First time what you are calling here, GCD of 36, 60 I am calling. Assume this is A, this is B. Just as an assumption, friends. Let us take this is A, this is B. So 36, 60. Okay. Next call, what you are calling? GCD of 24, 36. Okay. Next. GCD of, next what you are calling? 12, 24. I'm just writing these numbers, friends. Okay. 12, 24. Next, what you are doing? 0, 12. 0, 12. Okay. Now see here. So first you are calling, this is the A value and this is the B value. 36, 60. Next time, what is the value of A is becoming 24. How did I got this value 24? How did I got this value 24? Actually, I have 60 I have taken. I have divided by 36. Whatever the remainder that I have got is nothing but 24. Everyone agree? Is it remainder or not? 24 is correct now. It is remainder, friends, 24. Okay. How in mathematically or in the programmatically, how we will get 24? Can I write 60 modulus 36? Can I get 24? Tell me. Yes, of course. If you write 60 modulus 36, you will get the 24. 24. Okay. Now from this 24 is nothing but 60 modulus 36. Is this point clear? Is this point clear, friends? Nothing else. Simple basic things only here. I'm not teaching any advanced things. Not teaching any simple things which have learned in our school days. Okay. So this 60 modulus 36 is the first parameter. First parameter, right? So this is nothing but, can I write this one as B modulus A? Yeah, this is same only, na? In front of you only I'm telling all these things. B modulus A. So next time, when I call this 12, what is this, friends? What is this 12? This 12 is nothing but 36 modulus 24. 36 modulus 24. So which is again B modulus A. Like that, I will keep on repeat the process. The moment when the first variable A becomes 0. First variable becomes 0. What is the output, friends? Whatever that value of B, that you can write. When A becomes 0, you simply return B as the answer. Otherwise, if A is equal to 0, you can happily return B as the answer. Otherwise, what you have to do? You call the GCD. With what are the two values? A modulus, this is nothing but 60 modulus 36, which is B modulus A. B modulus A. B, friends, 60 is B. Here if you see 60 modulus A, B modulus A. Okay. What about this 36? This 36 is nothing but A only. A only. Over. Story is over. This is the code for finding GCD. Let me write it here. Check this. If A is equal to 0, return B. Okay, if A is equal to 0, return B. Otherwise, else, return GCD of B modulus A. Now I know you might getting some doubts. I'll clarify those doubts. B modulus A, comma A, comma A. Yes. Now the doubt which you might be getting is, sir, this is okay. See, how did I wrote this code? Just I have taken one example and I wrote a code. Now you might be getting, sir, what if GCD of 60 comma 36? I hope this is the doubt you might be getting in your mind. What will happen? What will happen if A is greater than B? I know you might be getting this doubt because I am teaching same thing from the past 4+ years. I know I have seen all the types of students and I know what students also get the doubts. Okay, let me tell you, does this code, see, even if GCD of 60 comma 36 also, it should supposed to give output as 12 only. Correct. Whether GCD of 36 comma 60 or 60 comma 36, it should give output is 12 only. Then only our code is correct. Okay, let us prove this. Now, when I call GCD of 60 comma 36, we have already became pro in tracing the recursion code. This is A, this is B. Now, is A is equal to 0? No. Then return GCD of B modulus A. What is B modulus A? If I do 36 modulus 60, what is its answer, friends? Whenever you are doing modulus, if the numerator will be small compared to denominator, whatever the numerator will be the answer. Therefore, this is 36 comma A. What is A? 60. Now again, check GCD of 36 comma 60. So don't you think they both are same? Don't you think the process continued from here? Same process. Over. Story is over. Okay, same. From here, it will continue. And finally, it will return 12 as the answer. So therefore, friends, whatever we have learned in the childhood, say in our school days, that time we don't know that is not a recursion. But we have already learned the recursion from there only. We have learned the recursion in our school days only, friends. But that time we don't know that it is a recursion. I hope you got it. And the meaning of this is Euclidean algorithm. This algorithm name is Euclidean algorithm. Therefore, in our school days only, we have studied about algorithms, friends. So in our school days only, we have studied about algorithm concept. Okay, but that time we were not knowing much about all these algorithms, this stuff, but we have learned that time only. Clear? Clear, friends? Okay. We will see the next question. Okay, now what is the time? 9:44. Okay. Let us start discussing about this problem we will discuss. So in the beginning, if you remember, starting of my class, I told we will solve this Tower of Haney problem. So this problem, starting I told, our end game is to design a solution for this problem. See, you will get a recording of it. Some students are asking, so can we get recording or not? You will be getting, friends. Okay. Now let's try to code it. Before coding it, first let's try to find out the logic for this problem, Tower of Haney problem. Very beautiful way I'll explain. Kindly see, friends. When number of, I hope now I'm not going to repeat the rules. I hope you know the rules. At any point of time, you can move only one disk, and on top of the smaller disk, you cannot put the bigger disk. Those are the two rules. First, if number of disks is equal to 2, see, always recursion, what we have done, some pattern we have identified, right? And that pattern also we will try to figure out it fit here or not. Okay. Now first let me take, if number of disks is equal to 2, let us check what will be the output. If number of disks is equal to 2. Okay, na? So if number of disks are equal to 2, it is very easy, friends. So first of all, I will take this bigger disk, this smaller disk. This is source, this is the destination, this is the auxiliary. Okay, just give me a minute, I'll take some water. Okay. Yeah, now where are we? Yes, 2 disks are there. First, I'll start the solution for number of disks are equal to 2. So if 2 disks are there, our ultimate target is to move all these 2 disks from source to destination. That is my target. Okay. So 3 poles are there. So first pole name I'm giving A, second pole is B, third pole is C, friends. So first step, what I will do, I will move this smaller one from A to B. That is the first step. So first step, I will move from A to B. Second step, what I will do, I will move the bigger disk. So this disk from A to C. Then this bigger disk will be moved to here, A to C. Then whatever the smaller disk, I will happily move to here. Because of this, what happened? Whatever the 2 disks that are present at source reach to the destination. So if number of disks are equal to 2, total, we got 3 moves. We got 3 moves. I hope is this clear, friends? If n is equal to 2, very easy. If n is equal to 2, very easy. Straightforward, we can bring it there. But the challenge comes when slowly these values are increasing. If it becomes 3, if it becomes 2, then the real challenge comes. If it becomes 5. Okay. So whatever the number of 2 disks, those A to B, A to C, B to C, I have written source to auxiliary, source to destination, auxiliary to the destination. Just I have wrote, maybe if required, I will take help in future. Okay, so I will take this help in future, friends. So let it separate it out. Now let us see further. Number of disks are 3. Then what is the story? Okay, so I will take 3 disks. First is A. So first it will be A, then B, then C. Okay, so let me take now total 3 disks I'm going to take. Now how to solve if number of disks are 3? So now concentrate here on the simple point, friends. The simple point is, if somehow if I can move whatever these 2 disks that are present, okay, somehow if I can move these top 2 disks to here, I don't know how I am going to move, but somehow if I can move these top 2 disks from A to B, then can I move last disk comfortably to here? I don't know how I am going to move, but somehow if I can move these top 2 disks from A to B, then I can happily move my last disk from A to C, A to B. I can move that. Okay, but how should I move? How should I move these 2 disks from source to auxiliary? So friends, you know already, if there are 2 disks are there, these are the steps we have to follow. These are the steps we have to follow. This we have already know from the previously. From the previously, we already know that if number of disks want to move from source to destination, these are the 3 steps we have to follow. Now here, our main target is to move number of disks 3 from source to destination. This is my target. My target is to move these 3 disks from source to destination. That is my final target. But to reach that final target, we are having small targets here. Here, what is the small target? I want to move these top 2 disks from here to here. Then for temporarily, this auxiliary is going to become the destination. Small target. What is the small target here? What is the small target? Small target is moving 2 disks from A to B. That is my small target. So if I want to move these 2 disks from here to here, then for the time being, this will be source and it will become the destination. If this is source, this is destination, then for time being, it will become auxiliary. It will become auxiliary for time being, friends. Okay, then what is the process? It is saying that first source to auxiliary. What is source and what is auxiliary? That is A to C. I'm just writing these steps. Then source to destination. What is source? A. What is destination after changing? Destination will be B. Then auxiliary to destination. What is auxiliary? C. What is destination? B. Okay, I will follow these three moves. And I will check whether these two disks are coming here or not. I will check it, friends. Okay, so for that, I will take this diagram again, because I am going to check whether can I reach my small targets or not. So first of all, here I am having total 3 disks here. Here my target is to move just only top 2 to here. Okay, so first step is A to C. A to C, then what? So this is A, this is B, this is C. So moving this one from A to C, then this small disk will be coming here. Then A to B, which means second disk is there now, this one. So which will be coming here. Then C to B, then the small whatever C, it will be coming here. Okay, I was able to reach my target. Correct now, friends? I reached my small target. Okay, once I reached my small target, then can I happily move this disk from here to here? Of course, you can move, no problem. Then next step will be A to C. Happily, you can move this bigger disk from here to here. Okay, half of the task is completed. Half of the task is completed. Very good. Now, next, we have to move these 2 disks also from here to here. Then what will happen? Then for the time being, this will be act as a source and this will be act as a destination. And once it is source and it is destination, this will become the auxiliary. And you know, if number of disks are 2, how to do the process. So what are those steps, friends? So first step will be source to auxiliary. What is source? Source is B. Source to what is auxiliary? That is A. Okay, B to A. Then source to destination. What is source? B. What is destination? C. Then auxiliary to the destination. What is auxiliary? That is A. Then what is the destination? Destination will be C. Okay, now I will follow these 3 methods and I will check whether can I able to move these 2 to here or not. First step is move B to A. So whatever B small disk will be go to A. Okay. Then B to C. Whatever this disk be, it will go here. Happy. Then A to C. Okay, happened. Completed, friends. Oral story is over. So in just 7 moves, we were able to done it. Getting? Okay. I hope as of now you understand. We have done for number of disks are is equal to 3. So we have taken a help of number of disks are is equal to 2. That help we have taken and we have designed this. We have designed this. Okay, we need to verify. Does it even work for, n is equal to 4 also? Let me verify what is there. So now I will try to write these, names, friends. So here, now again, original number, original names. So A will be the source, B will be the auxiliary, C will be the destination. First, A to C, source to destination. Then A to B, source to auxiliary, source to auxiliary. Then C to B, C means destination, B is auxiliary. Then A to C, source to destination. Then B to A, B means auxiliary, A is nothing but source. Then B to C, B is auxiliary, C is nothing but destination. A to C, A means source, C means destination. So if number of disks are equal to 3, this is the strategy we have to follow. If number of disks are equal to 3, this will work, friends. This will work. Okay. Now, I should even check it for number of 4. If n is equal to 4, it is working. Happy. Comfortably, we can take. Now, I will prove this for n is equal to 4. n is equal to 4. Okay. Now check this carefully. Same names we have wrote now. So let me reconfirm again. A to C, source to destination, source to auxiliary, destination to auxiliary. A is source to destination. Okay. B means auxiliary to source, auxiliary to destination. A means source. C, okay. Perfect. Perfect, friends. Now, you see, A is source, B is auxiliary, C is destination. See, for the time being only those values will be true. For the time being only these values are true, friends. Okay. Last. Now, final. Now, I have to check for number of disks are equal to 4, whether it will be true or not. Okay. So, I am going to take total 4. 1, 2, 3, 4. Now, first, somehow if I can move these 3 disks from here to here, then I can move this one directly to here. Correct? Okay, let me try. A, B, C. A, B, C. Okay, now top 3 disks. Top 3 disks, I want to move from where to where? From source to auxiliary. But temporarily, it is going to become the destination. For the time being, it is going to become the destination. Once it is destination means it will be the auxiliary. Now I will follow these steps. This will be n is equal to 3. Okay. So now first step number 1, source to destination. Source to destination means A to B. I am writing all the steps. A to B. Source to destination. Then source to auxiliary, which means A to C. Then destination to auxiliary, B to C. Then source to destination, so A to B. Then auxiliary to source, C to A. See, I'm just following these names, friends. That's it. I'm following this. From here, I'm trying to write. Okay. So 1, 2, 3, 4, 5 completed. 1, 2, 3, 4, 5 completed. Auxiliary to the destination. C to B. Source to destination. So A to B. 7 steps are completed. Okay. Now let us see if I follow these steps, can I able to place these 3 from here to here or not? Because that is what it is telling. Okay, let me check. If it really works, then happy. Okay, now check carefully. So I have taken separately one diagram, friends, to write that. Okay. First, what it is saying that first total 4 disks are there now. 1, 2, 3, 4. I'm just following. Okay, those steps. So this is A, this is B, this is C. Now check carefully. First to A to B. So this A, smaller one, B means it will be coming here. Then A to C, second one will be coming here. Okay, A to C. Then B to C. So this smaller one will go here. Okay, B to C. Then A to B. So this second bigger one will be coming here. Okay. Then C to A. So see this smaller one. So what will happen? All these 3 are gone, right? All these 3 are gone. Okay. So next C to A, which means whatever on the C, it will coming on the very smaller one. Next C to B. So now C to B, second smaller one. Okay, it will be coming here. Then this is also completed. Then A to B. So A smaller one is there now. So it will be coming here. Okay. If you observe carefully, did we reach our small target or not? Tell me, friends. Did we reach our small target or not? Yes, we have reached it. Okay. Then what is the next step? Next step, you do A to C. Okay. What I'll do? I will move this bigger one. To C. Next, now my remaining target is to move these three from here to here. Then what will happen, friends? If you want to move for time being, it will become source. Okay, for a time, because from here I want to move. So this will be source. This will be destination. Then this will act as a auxiliary. Now I will try to write the moves again by using this concept. So source to destination. So let me write all this. So source to destination, which means source to destination, B2C, B2C. Then source to auxiliary, B2A. Then destination to auxiliary, destination to auxiliary, that is C2A. Then source to destination, B2C. I'm just writing by seeing this. Okay. Auxiliary to source, auxiliary to source, that is A to B. Auxiliary to destination, auxiliary to destination, A to C. Then source to destination, source to destination, B to C. Now let me check whether this will work or not. My final target is to move all these four from here to here. Now let me check. Okay, I have written all the moves also. So let me remove all this. Source, these names also. A, B, C. Let me write again. This is A, B, C. Now check. First step, B to C. So whatever this B, smaller one, will be coming onto the C. Okay. Next, B to A. So whatever this is present B, it will go here, which means second one, B to A. Then C to A. So whatever smaller C, C2, the smaller one will be coming here. Okay. Next, B to C. Whatever present on the B, whatever present on the B will be going on to the C. So this is not completed. So this will be completed. Okay. Next is B to C, which means this bigger one, second bigger one will be coming here, which means this is also completed. Okay. And inside this is also done. Next, A to B. So smaller one will be coming here. So this is done. Then A to C, this bigger, this one will be going there. Okay. Then B to C, the smaller one will be going there. Successfully done. We have reached, friends. Number of disks also equal to 4. Done, na? Understood? Now if they give n is equal to 5, can you able to do? Tell me. If they give n is equal to 5, can you able to do? Yes. First do for 4 moves, then do for 1 move, then do for the 4 moves. Now you need to count the total how many moves are required. First, for n is equal to 2, you know that 3 moves are required. Next, for n is equal to 3, how many moves are required for this 3? Plus 1 plus another 3 moves. If n is equal to 4, 7. So 7 plus 1 more move plus 7 more moves. So which will be 14. Next, when n is equal to 5, okay, so 14 moves plus 1 more move plus 14 moves. So which will be 31. Okay, sorry, it will be 15. 15. So it will be 15. So 15 plus 1 plus 15. So which will be 31. Okay. Now, what is the formula, friends? 2 power n minus 1. 2 power n minus 1, friends. So these many moves are required. These many moves are required. Okay. Now, I hope you take this knowledge and try to write the code, friends. Now try to write the code. Have a try. Okay. So that's it for the class. So big thanks you to all. Okay, so then friends, so let me stop the screen. Okay, I will share all this, whatever the notes that I will share it with you, friends. So let me stop the recording. Okay, I will stop. Yes. Done.
Thank you, Venu. Thank you for this amazing session. I hope you guys really enjoyed it. They are actually, you can look at the chat, Venu. They are like, it was a great session.
Thank you. And see, I want to thanks to all of my IAs also, because they helped a lot. Without them, it is very difficult. So thank you for each and everyone So Sumit, Prakash, Prajwal, Vivek, Pooja, and some of them are already dropped. So for all of them, big thanks. And thank you, Sakshi.
Thank you everyone for joining the session. We'll come up with other sessions as well on DSA. So keep joining, keep attending, keep learning, and leave the session with a bag beaming with knowledge. So yeah, people, thank you, Venu. Thank you, everyone. Good night. Have a nice day. And
Thank
bye.
you. Good night. So soon we'll meet in next masterclass. Yeah.